Is this our 6th year or 7th year?
Ooh, tough question.
Lost count of that.
Somebody jump on the OpenSIPS.org site. Start looking at
doing that.
archives.
I'm doing it. Hold.
Come on, we're all in denial about those about
That
us getting older.
We had microphone. That's one.
Okay, let's see.
Make it 10. Say the first four were private.
So yeah, first Amsterdam was 2015. So 5 years ago, the first one in Amsterdam.
Wow. So that puts us at the 6th version of this, right? 5.
Okay,
6,
I think we're live.
7, 8, 9, 10.
Good. I think
We're live.
Yeah, OpenSIPS
Right.
2020. We're starting.
Hello, everyone. I hope you're all got yourselves comfortable and ready to absorb some amazing stuff that we have for you today. Just to let you know, this is going to be running for the entire week, basically. Well, not the entire week, but most of it. Today, we're going to have some interesting discussions, but first, I want to talk about this being our 6th year and how disappointed we were that we weren't able to do this live in Amsterdam. I know that disappointment is shared not just among all the people involved in the project, but everybody that's here today. Everyone would much rather be in the city of deceit, and unfortunately, we couldn't do it this year. But we did put together an amazing week of summit presentations for you. Interesting topics, great conversation. And I want to go over some rules to make sure that this is as civil as it can be. For all of you that are on the Slack channel right now or in Slack, thank you for taking the time to get registered in there, and make sure that you're inside the chat, inside of the raffle, and the summit itself. There are 3 channels. Moderators will be taking questions from both the Slack Summit chat as well as the chat in YouTube. So if you have a question, most questions will probably be taken care of at the end of each presentation, but make sure that you make it visible inside both of those channels so that it's not lost. Another thing, every day at the end of each session, we're going to be, well, not at the end of each session, but at the end of the day's sessions, we're going to be raffling off some amazing prizes. One of them is going to be one of these great OpenSIPS distributed 2020 t-shirts. And you'll be getting some opportunities to work with members of some of the best open source projects related not to just OpenSIPS, but the world. Today, we're going to be raffling off one of these, did I mention, amazing t-shirts. And 1 hour, we're talking about 60 minutes, 3,600 seconds. That's your TTL, everyone. You'll be spending that with the entire OpenSIPS team. You can bring your ideas, your wildest ideas, or you could just sit there and look at each other. Nonetheless, the time is yours. But there is one very particular rule that you have to take into account. You need to be inside of the Summit raffle channel at the time of the drawing in order to be eligible. We have an amazing AI that we spent 6 years building, integrated it with Slack, and this AI will be choosing the winners of the raffle. By the way, that's built on the OpenSIPS 1.11 engine. So just so you know, it's not perfect.
It's not distributed.
It's not distributed, unfortunately. That's correct. We have some great moderators. We have the entire OpenSIPS team here. We have people from all over the world. And I want to really bring some attention to our really good friend, Maxim Sobolov. He's the one that's taking care of pushing all of this content, making sure it's available to all of you while we're presenting. And when we're done, all of this will still be available on YouTube channels, so you'll be able to watch it and rewatch it and rewatch it. We thank you all for coming here. This looks like an amazing turnout. I just want to point out that sitting inside of the raffle room right now are 347 lucky contestants. And in the chat, we only have 41 people that have questions already. Without further ado, I want to present to you all the founder, the genius, the man that can't grow hair, Mr. Bogdan Iancu, the founder of OpenSIPS. He'll be kicking us off with his keynote. Welcome everybody to the 2020 OpenSIPS Summit Distributed.
Thank you, Alex. And welcome everyone, speakers, moderators, organizers, and the last but not the least, the participants, because at the end of the day, that's the reason why we are running this show, just to keep everyone connected to what's happening into the OpenSIPS world. And as Alex already mentioned, because of this, let's say, special, or whatever you want to call it, context, this year we had to go for the online and to a more compact format. And because it's an OpenSIPS summit, we focused on mainly on OpenSIPS and the direct connection of OpenSIPS with other projects. Just again to try to deliver a more focused content. Having that said, I will share some, let's say, insights of the OpenSIPS 3.1 release. And yeah, Voodoo. Okay. You know, we are all used to say in most of the presentations, we start with a bit of the history of the project. When let's say the project started, when there were some the major events during the lifetime of an event, you know, and things like that. But in my opinion, in terms of history, the most important is the history of what I called the history of the vision of the project. So what was the idea when we created this project, or when we started the project? What is the current and what we want to be our vision? Fortunately for us, it's the same. So we haven't changed a thing when it comes to the vision of the project. You know, the history of this bundle of projects, it's not simple, it's complicated. It stretches for more than almost like 20 years ago. But in terms of OpenSIPS, what we are keen and for, and what we are following is, first of all, the most important is to play as an open source project, and open source not means just sharing the code. I mean, that's not necessarily the whole idea of the
Okay, Bogdan, I have some
Yeah.
audio issues, so if let me check what's going on.
Is it something on? Okay.
Move your mic or keep your mic closer to your mouth a little bit.
Oh, okay. So I thought it might be the network, but okay. Much better. Sorry.
Hide your
Yeah,
mouth.
I think the mic was, you know, rubbing against the T-shirt or something like that.
Hold on, they say it's on a specific room for some reason.
I don't think it's on your side, Bogdan, because we hear you quite well here. Maybe it's just on the stream.
Yes, it's probably on the stream. Just give me a second. I'm trying to figure it out.
Okay. No worries. We have some some time reserved for such problems.
Seems that the audio has only problem through YouTube. We can hear very well here, we moderators.
Okay. Well, I got scared for a moment that okay, we need to boost our contract to the internet provider. No.
Okay, I think it's better. So
Okay.
should be cool at
Yeah.
least.
Okay.
Can you all throw some feedback in the chat room? Let us know if you're hearing it okay on the YouTube.
Okay. Yeah, let's see how it goes. I think I saw a lot of positive reactions from there, at least on Slack. So yeah, continuing with, I guess people got scared about the vision. Okay, so the vision of the project, it's first of all focused on open source and all the ingredients of open source, meaning community interaction with the people providing help, working out contributions and things like that. Also, another important point of the vision is we like to say that okay, OpenSIPS, it's an industry-driven project. Basically, we like to work on the project and have a goal, its usage, by different providers. So we are happy when we learn that okay, people are actually using, and OpenSIPS, it's solving, let's say, addressing real needs of carrier, ITSPs, different kind of service providers, and so on out there. So yeah, that's what keeps us motivated, just to see that it's heavily used. And the last but not the least, also very important, we try as much as possible, because it's almost impossible to be in real time, but we want to be up to date with let's say all the the news in terms of SIP, in terms of trends when it comes to in terms of VoIP and RTC and things like that. So we want to be sure that we are all the time having more or less the latest features included into the project. And yeah, because we are talking about the history, let's see in terms of releases a bit of, again, history of open source. In the last, I guess, 5 years, we are trying to have to put a label on each release. So we want to concentrate our effort on a particular topic on the major releases. In that case, we can boost the value of that. So, for example, with the OpenSIPS 2.3, which was, I think, roughly 4 or 5 years ago, we focused on integration with other projects, with Homer, with FreeSwitch, with maybe other protocols and so on. But the idea is, again, the idea was to aggregate our efforts into a single direction, so we can give some big weight on that. Again, historically speaking, then we had the 2.4, which was focused on clustering, and that was a big achievement in terms of a project, getting the clustering engine and a lot of modules being able to to do the data sharing, real-time syncing, and so on through the clustering layer. Last year we had the 3.0, which was focused on DevOps, how to simplify the life mainly for the operators, for the OpenSIPs, for people running OpenSIPs, because at the end of the day, it's not enough just to have a very good piece of software. You have to make it, let's say, runnable. So for people to be able to, operate under safe and reliable conditions. And for this year release for the OpenSIPS 3.41, we had the call crafting, and we're gonna see exactly what that means. But before jumping into that, I'm just continuing the numbering, so getting to the OpenSIPS 3.2, which will be the next release. And because we are open source and we like to get any kind of input from community and community and industry driven, if you can contribute with ideas in terms of what should be done in 3.0, I have over here an Google form for that. The link will be distributed over the YouTube chat or by Slack also. So feel free to, again, provide your input in terms of what should be, what is needed to move on with the 3.2.
And Bogdan,
Yep.
if I'm not wrong, the 3.1 is a long-term release, so big deal.
Well, yes, that's it's not mentioned, but you are perfectly right. 3.1 would be, I mean, it is on LTS. So we are quite keen to make it a really stable release. And as an open source project, as developers, we also heavily rely on the community in order to provide a lot of testing and reporting, so we can provide fixings, because at the end of the day, OpenSIPS is a quite complex beast in terms of piece of software, and it's almost, I wouldn't say impossible, but it's a quite huge task to perform all the possible tests. I mean, they are like probably huge, almost like infinite numbers of configurations that you can have in terms of scripting. So yeah, impossible to test.
As you tell a lot of times, there is so many usage for OpenSIPS that we don't even think about. I mean, people come out and companies come out with totally new usage that are not envisioned since before. So, I mean, very interesting use case and test cases.
That's perfectly right. I mean, it happened not only once. When, let's say, releasing a new feature and somebody already, let's say, used it in combination with something else. We never thought about that combination, and because we never thought, we never tested it. So yeah, there might be potential surprises, like they may not work together, or they might have problems, and so on. But as I said, as you said, people uses so many combinations that we actually quite a lot rely on the community to perform tests and to report. And actually the GitHub tracker for OpenSIPS, it's quite an active one in terms of reporting, discussing about issues, feature requests, also fixing, and so on. sometimes it's like a more activity over there rather than in terms of asking for help in terms of how to use it. Probably that's thanks to the good documentation we have. Just kidding. Okay. So yeah, please try in the next days. I'll try to compile a kind of let's say answer by the end of the event. So by Friday, just to see exactly, you know, what people would expect from the next release. But going back to
just
the
a quick question, Bogdan. People ask
Sure.
to post that link to chat or Slack channel.
Yeah, if anyone in the
It's there, guys.
okay. So just yeah, copy paste. Otherwise, we will redistribute it again. But should be on Slack and also on the YouTube chat. Going back on the 3.1 to the present. Again, some history, because it will be relevant in terms of what 3.1 tries to achieve. Originally, when the first line of code in the long history of of this code was written, that was 2001 with the SIP Express router. At that stage, it was more or less a quite straightforward, stateless or transactional SIP server. Nevertheless, transactional meaning just request replies, nothing more. I remember, I think it was 2001, 2002. In Focus Institute, we had Andrei. He wrote most of at the time quite a large part of the SER core. The transaction module was one of the actually was the first module trying to get this transactional layer in use, and we were thinking like, wow, how many people will actually use transactions, so stateful transactions in SIP, because again at that time it was more like stateless, so very, very simple, and because of the stateless, more or less you were not able to do almost nothing. I mean, not to even detect like a call failure or something like that. So in terms of let's say SIP, the capabilities of SIP stack originally was a stateless proxy, and again as a module we had the transaction module. I was working on that together with Irji Kutan. He was let's say translating the RFC for us, just in terms of how should it work. And at that moment was more or less sufficient, but later in time, based on what people were trying to do with SER at that moment, we ended up with the need for something more. I mean, not only transaction, but we at the time I was already OpenSIR. We had the need for dialogue support. Basically, started with the idea of being able to track, count dialogue. So just simple, quite basic things related to the dialogues. But that was a real need, and the dialogue module was added. So that was a step forward from transactions. We got to the dialogue level support. Then 2009, 2011, we already had OpenSIPS as name for the project at the time. Then we got the back-to-back support into OpenSIPS, again a module that actually allows us to act as a SIP back-to-back to break the caller and the callee legs. So again, it was one more step in terms of the complexity of the SIP stack. Later years, up to now, this dialogue support got more and more advanced with different kind of additions in terms of handling in dialogue data, what you could do, like doing the pinging, controlling the duration of the dialogues, and so on and so on. And now everything, let's say, escalated with this year when we had this call crafting. So basically the ability to handle complex calling scenarios where OpenSIPS has the ability to play with the CPUs as a SIP user agent client and user agent server in the same time to initiate calls, to manipulate SDP between calls, to exchange them between the calls, and so on. We're going to see later. But I just wanted to have a bit of a history in terms of, again, the capability of the SIP stack, starting from a simple stateless proxy, transactional, having dialogues, back-to-back support, and now trying to fit everything together in order to achieve more complex scenarios. So with handling multiple calls, syncing between the calls, and so on. So yeah, OpenSIPS 3.1, as we like to say, so far we flexed the muscles. We tried to put a lot of traffic, throughput, how many registrations, how many thousands of calls, and so on and so on. But in the same time, we should not neglect the, let's say, the brain side, basically to increase the complexity of the logic in OpenSIPS, because even if you can do a lot of things with OpenSIPS in terms of scenario, you still have to learn a lot in terms of SIP. You have to work at low level SIP traffic, so this might be a bit too, let's say, complicated in several scenarios. So that's why with the 3.1 we try to abstractize to create abstract elements for the SIP user agent clients and user agent servers, so you can easily work with them. To also have the possibility to interact and exchange data between the call, because this allows you to create more complex, typically class 5 scenarios, or better interaction when it comes to the media side, because we have to admit, by design, OpenSIPS in all the shapes and history never had any kind of direct RTP support. We are relying on external apps for that, like RTP Proxy, RTP Media Proxy, and RTP Engine, historically speaking. So yeah, we need quite a good interaction with all these external softwares in order to do cool things with the RTP. And actually, Razvan and Maxim will talk a bit more later about this. And when we had all these extensions at the SIP level, then we can build a lot of things on top of these SIP entities. For example, we can create more complex or advanced feature bar, combining dialogues with the capability as a dialogue level with the presence level, like the BLF, DFKS, and so on and so on and so on. Taking a look of the most important additions in 3.1, one is the call API. And as the name says, it's an API that allows you to run, manage calls through OpenSIPS. Because OpenSIPS, historically speaking, it's a proxy, that means that you OpenSIPS expects to receive calls and then to send them further, more or less, that's what a proxy does. But with the call API, we try to grab a full control over the call, and the actions in OpenSIPS are not necessarily triggered by incoming traffic, but they can be triggered by external entities, by other apps, portals, and so on. So shortly said, you may have a web portal that starts calls through OpenSIPS that can trigger a transfer or can put on mute a call in OpenSIPS. So all these are first of all triggered through OpenSIPS, so you don't have to trigger through SIP, and everything is done in terms of signaling by OpenSIPS in an encapsulated way. So if we are looking at levels at the bottom, we have the typical, the SIP stack that it's accessible by the OpenSIPS routing config. So you have access to all, a low-level access to all the basic elements in SIP, but it's very difficult to put together in order to do complex stuff. Next level are the SIP entities, which are provided by different kind of OpenSIPS modules. Like you already have a concept of a dialogue, of a back-to-back. Then the call-ops module, it's doing even more. And at the top, we have the call API, which offer you an abstract representation of a call, so you don't even have to be aware of SIP. So provides you quite a complex element, but something very easy to use in order to, as I said, start, stop, transfer call, put on hold, and maybe more in the future. But the idea is to provide, to encapsulate complex SIP scenarios in a way that are very, very easy to use from outside OpenSIPS, basically with any, without necessarily quite a deep SIP understanding. That's just a quite fast diagram of how this call API works. It's WebSocket based. It's a bidirectional, so you trigger different kind of actions into OpenSIPS. In the same time, you get a lot of events with what happened with the calls. This call API is an external application. It talks to to OpenSIPS, which controls the SIP and sometimes the RTP also. For more details on that, we have the next presentation. I don't want to get into too many details, not to be a spoiler. We have Razvan talking about the call API in 3.1. Another great addition was is the media mixing. Why it's so great is because, as I said, OpenSIPS does not directly operate with the RTP. I mean, probably you are used with Asterisk, with FreeSwitch, where you have the signaling and the media together, so you can do a lot of things when it comes to the media. Well, for OpenSIPS, it's not the same, because the only thing that we directly have access is actually the SDP. We don't directly have access to the RTP itself, so we have to rely on external components in order to deal with the media. But in the complex call scenarios, you cannot deal only with signaling. All the time, it's also about media. You can do, okay, I want to do music on hold. Okay, somebody has to stream the music. Or I want to do a call parking. Well, okay, somebody has to play back some, when you park the call. All the time, media, it's there. So you have to have some tools to allow you to operate with the media. And for OpenSIPS, that's the so-called media exchanger module. What's the idea behind? The idea is to have OpenSIPS still acting as a proxy. So between A and B, you still have a proxied call. But when it comes to the RTP, by passing it through, by having control over the SDP, you can actually individually control the RTP streams going to A and B by, again, operating as the SDP level. Basically, in this example, like we try to do an RTP injection during a call. So basically, in terms of signaling, we don't replace calls. We don't change. We don't have separate legs or anything like that. We still have the SIP1 call between A and B. We just use reinvites in order to inject different SDPs, which are collected from different calls. So basically, we take the call from a media, we get the RTP from a media server by using different SIP calls, and then we just grab the SDP and we push it into the original call. So by doing that with the reinvites, we are able to, in this example, to inject custom RTP in an ongoing call. In a similar way, you can do also RTP forking, basically to grab the RTP from one side, from both sides, in order to do recording or features like call listening or call barging and stuff like that. So again, trying as much as possible to keep the model of a proxy by using reinvites and mixing the SDPs between the different SIP calls. We are trying to get the RTP media from a media server, also through SIP, and mixing it with the original call. On Friday, Razvan will have a presentation on that with more details and some cool demo on how you can do the media exchanging. And because we are talking about the media, also in that area, we have the Dtmf Interception feature, basically using an external RTP relay. It can be RTP proxy or RTP engine at this moment. OpenSIPS can receive Dtmf notifications at the script level, and in a very custom way, you can decide, okay, what to do with those notifications. Notifications may trigger, let's say, changes into the signaling, may trigger changes, non-SIP changes. For example, you can interact through any queuing or REST interface with external elements, and so on. There are some great examples on how you can use the Dtmf sampling from RTP level with the media exchanger in order to, for example, trigger some fancy on-hold, off-hold, or to insert like authentication PIN number, or simulating kind of an IVR. For playing different kind of, for injecting different kind of announcements from outside, and everything again by acting as a proxy. So you don't have to go into the actual back-to-back area or anything like that. You have a proxy called and grabbing Dtmf and using custom scenarios for injecting RTP by SDP into the call. You can actually create really cool stuff.
Bogdan, so if I understood correctly, you're envisioning and you're delivering an extremely scalable, IVR capable and media capable engine. So, in the future, we will no more think about OpenSIPS as only as a proxy for signaling, but it will allow the community, will allow also very big operations into having simple media services without using directly asterisk, free switch, or things like that. It will be limited to OpenSIPS and RTP engine, RTP proxy, or some that is so much scalable. This is big news.
Almost there. You definitely need an media server in order to generate the RTP. So OpenSIPS will not generate RTP at all. What OpenSIPS will do. So basically, you'll still need, let's say, whatever free switch or asterisk in order to generate the media itself. The idea is you can take the RTP generated through a completely new call let's say from free switch, and I can inject it into an existing call. So as the name says, a media exchanger, it's not generating an RTP, but RTP stream, but can replace the RTP streams between calls. So I can keep my original call ongoing, and then I can create, for example, a separate call to free switch, make free switch to play something, and I just grab that RTP stream and feed it into my original call with a simple reinvite to the new SDP. So basically, I'm just doing basic signaling into an existing call, like a reinvite, in order to feed in a completely different stream from a different SIP call. But again, I still need an SIP media server. But yeah, I mean, it's definitely true what you said in terms of scalability, because in that case, OpenSIPS having full control in terms of the calls as a signaling, then I can have a cluster of or a distributed set of media servers generating the RTP, and with with a single OpenSIPS just doing the mixing of the SDP between the calls. So basically controlling the whole process of injecting the RTP into the existing calls. So yeah, also for this topic, it's not only about injecting, can work in the other way around, like grabbing media from existing calls. So it works in both directions. With a media exchanger, yeah, the DTMFs can control this kind of SDP replacement. On Wednesday, Razvan will run some presentation on and demo on that. Believe me, you can do really cool things. Also on Wednesday, Maxim Sobolev will also give us some updates on the RTP proxy project, so we can see how everything will fit together. So far, we talked about quite high level concepts like API, or how you can play with the call at an abstract level. Nevertheless, in order to achieve a good control over the calls, we have to look quite closely to the to the low level in terms of SIP signaling. And in this area, we have the push notification, actually in 3.1, which is an accurate implementation of the RFC 8599, which is the latest. It's last year released RFC in regards to push notification for SIP. There were specifications for a push notification with SIP even before, but they were a bit loose and maybe not covering everything. For example, this new RFC basically unifies and cover all the aspects in terms of SIP with push notification, in terms of how the endpoint, I mean the SIP user agent, should create and maintain a session with a push notification server, and then how to share the information about this push notification server with the SIP server. And okay, once the SIP server becomes aware of this push notifications session, how it is used during different kind of SIP scenarios, like how it works in terms of registrations, refreshing, how you do push notification when you want to establish a call, or even worse, actually worse meaning more complicated, how you do the push notification for the in-dialog request. So things are a bit more complicated. It's not only for triggering a quick registration, as probably most of us are used to, let's say covering all the aspects of SIP. So that's a great addition of this RFC. And tomorrow, Liv, you will get quite a lot in details with the presentation and some demo about this new push notification supporting 3.1.
There's no demo.
Okay, just presentation. That's one of the tricky things with the push notification, because you know, it's like how to say, a three-party marriage, because you have the user agent, the device, the end device. You have the push notification service, which complicating things may be provided by let's say for Android, for iOS, or for whatever. And then you have also the SIP server. So all of them have to talk and eventually play by the rules in order to make it work. So yeah, when it comes to putting together like a demo, it's indeed it's not so.
Wait a second. Wait a second. How long does he have between now and then?
So okay, he's doing tomorrow like a typical 1-hour session overall.
I'm going to start a GoFundMe for this to happen.
Well, leave his address, so don't be shy. Okay, and yeah, because we keep talking also about the low-level, cool aspects of controlling calls and stuff like that. We have the steer and shaken addition into OpenSIPS. I don't want to be a spoiler on this area. We have this support since last year. Basically, steer and shaken, it's a how to say, like a distributed way to authenticate and verify the caller ID of the call, just to prevent caller ID spoofing, robocalls, and things like that. And in terms of the signaling, I mean, interacting with the signaling and performing the jobs, OpenSIPS can perform both the authentication and verification. So can insert, let's say, on the carrier side, all the information about that. It can verify it on a provider side or vice versa. So covers in terms of functionality, everything, and also provides different kind of usage models in terms of how you want to operate with the certificates, because okay, this part is still a bit under discussions or still settling a bit. So in terms of certificate managing, it can be completely unaware, so agnostic from this perspective. Or also it can do like a self-managing, like fetching certificates, caching, and stuff like that. And yeah, Vlad Petrashko will give a presentation tomorrow with more details about the steer and shaken stuff. Because again, when it comes to complex call routing, we want to cover the whole, as many aspects as possible for this topic. For the 3.1, we have the quality-based routing. That's an old idea we keep, let's say, flirting around, and it seems that 3.1 was the lucky number, a lucky version for this quality-based routing. I don't know, Livio, do you remember for how long we have this on the pipe? Because to be honest, I lost track of it.
Actually, yes, I do. I think it's since 2015.
Wow. Okay. So yeah, it was a really difficult birth for this model, for this feature, like 5 years. Wow. Okay. What's the idea with the quality-based routing? As the name says, instead of doing prefix-based routing or anything like this, you may also want to first learn about the quality of the calls. By quality, meaning different kind of parameters at the signaling level, like PDD, AST, ACD, and stuff like that. And depending on the quality given by these statistics, you may control your routing. So basically, you want all the time to hit, in terms of routing, the gateways providing the best quality. And the good part is that everything is automatically. So OpenSIPS is continuously learning and updating these statistics based on the ongoing traffic. So you don't have to, let's say, pre-populate any kind of data from this perspective. And based on the collected statistics, it will automatically update, so in real time, the list of destinations for the routing, so that the first used one, it's all the time the one offering the best quality. But Liviu will show more on this on Thursday. It's a quite cool things addressing some real life need.
On Wednesday.
Okay, sorry, Wednesday. Yeah, actually, tense is Wednesday. Yeah, okay, Wednesday. Thanks for the correction. And okay, because I'm running a bit out of time, we have actually many more other features in OpenSIPS 3.1, like the dialogue enhancements, basically the ability to access dialogue and accounting information between the calls. This works nice when you want to put together, scenarios like a call transfer or call parking or call pickup. So basically, in a scenario where multiple calls are involved and you need to coordinate and exchange information between them. So all these additions for the 3.1 in terms of dialogue, dialogue context information, that's really cool. Yeah, it's even cooler because I will talk about that on Friday, and have a demo to show how you can do that. It's not September, it's September, but yeah, okay. So this will be covered on Friday. Then something that Vlad will show on next Monday, so in 1 week from now during a workshop, we have the digital feature key support, sync, sorry, support, which is basically a concept introduced by Broadsoft, I think, which allows you to synchronize the status of a feature between the server and the phone. Because, for example, for setting the do not disturb or call forward, you can do such control over the feature both from the phone itself or from the, let's say, application server or from the server side. And the idea is to keep them in sync. Doesn't really matter where you do it. So you can do it from both, but the idea is just to have a single status. And that's something that it's done through presence. So actually it's a really interesting feature, and also the design of the module. It's really nice because it allows you to scale, let's say, for the future with multiple with more features, not limited to DND or call forward. Also part of the work of Vlad, we start investing more and more into the back-to-back user agent. First step was adding the clustering or the replication support for the back-to-back. Next steps will be to extend this support to all the modules using the back-to-back layer, like call center, in order to achieve not necessarily distributed capabilities, but also to get high availability. So basically replication for HA purposes. In terms of combining features from different SIP layers, like dialogues and presence, 3.1 has an extended support for BLF. The BLF is a quite used features because in a setup there are different kind of components that may want to know the status of a SIP terminal, like if it's a call available or not. For example, in call parking, you want to know what is the status of an parking slot, or in order to do transfer, you want to know the status of the other party, or similar for call pickup. So the idea of sharing the call status of people or services, it's a really needed feature. And even if this BLF support exists for quite a long time, we updated this in 3.1 in order to properly work for the during the serial and parallel forking. So these are some pretty cool additions that helps you, for example, when implementing call hunting or hunting groups or call forward, in order to get the proper publishing for BLF. Contribution from Vlad Paiu, the rate cacher, which is kind of a postpaid engine for OpenSIPS. So besides existing options, now you have another one directly into OpenSIPS. And one of the last on my list, it's the JWT authentication. Actually, authentication over the JSON web socket. It's a quite used authentication way when you have, let's say, multiple layer of authentication. Like first, like in WebRTC, first you authenticate in a web portal, and then you have to authenticate also in SIP, and so on and so on. So to avoid multiple authentications, you can, let's say, reshare the already existing authentication. So that's the JWT authentication support. Vlad Paiu, the developer, and I think with together with Shlomi Goodman, they will talk about this on Thursday. They will give a detailed presentation about this new edition of 3.1. And I think there are like many other, or it's a long list. I tried to cover the most relevant, and I think I still have 3 minutes for questions. So yeah, sorry for speeding up at the end. But yeah, there's quite a lot to talk about this new release. So
okay, the chat channels. Let's get some questions.
Yeah, I'm ready for it.
Yeah. So
yeah, well, for questions, Bogdan, I also wanted to mention that we are going to run. If you're interested, for example, in stir shaken or maybe some of the push notification scenarios, we're going to run a little bit of interop test next week, Monday and Tuesday. So we'll hopefully have a chance to play with those between different implementations.
Yeah, that's a good step, as Maxim mentioned, on next Monday and Thursday. Maxim is running this OpenSIPS interoperability testing, where we want to try to put together different implementations for various features and hopefully make them work together.
All right, I don't think we have any questions on
yeah, I was also going to answer, I mean, add something to Giovanni's question regarding replacing a media server. No, we're definitely not doing that, but we're definitely helping scaling all the this kind of platforms. For example, you will no longer need pin your call to a specific free switch instance. Let's say you can have the call proxied and then just use different available free switches for an announcement or something like that. So this will definitely improve the performance, or it will definitely scale up.
We have our first question. This is from Adam Jeffrey. He wants to know
Information.
minute detail.
I'll ask again during the presentation, but there is also some implementation that can do like broadcasting, like to have one call stream from the media server, for example, that is broadcasted to many other calls.
You mean in OpenSIPS or in FreeSwitch?
No, through OpenSIPS media capability.
Yes, that can be possible. As far as I know, we're now limited to only one stream, but that can be easily done, like having more. Actually, I think this was a limitation in an older version, but now we can have multiple streams, like forking the media to multiple participants in different calls, probably. So I think this is available. I will have to double check on that. But yeah, there's a question.
This can do some bizarre environment for a very scalable conferencing system where only one can speak at once.
Yes, we can do that, but yeah, more or less, because in a call, there's only one stream bidirectional. The other ones are unidirectional. They're only listening streams. Regarding, so there's a question regarding what's the roadmap for the call API. I will present in like a couple of minutes, so I won't answer this question right now. But there are a few other questions.
Yes, there are.
Yeah. Not sure if we should take care of them now or.
I think two of them actually kind of are together. So maybe we'll do Adam and Stas's questions together. Adam wants to know what's the roadmap look like for the call API, and Stas in that wants to know why the WebSocket was chosen for the call API. Were there any other protocols considered during the design?
Yes, but
I think let's because the next presentation is actually about the call API. So if the questions are related to the call API, I think let's buffer the questions for the moment. These ones have Razvan enlighten us with the call API details, and then yeah, we can address these questions.
Okay, is that okay with everyone else? Is there going to be protests?
hope not.
We're ready for no other questions. We will be much tougher after.
So there was one odd question out in all these. Do you want to maybe just consider it real quick? The OpenSIPS rate cacher module. Can we think of that module as a replacement for CG rates? And if we don't want to use third-party billing solution, we can use lightweight rate cacher module. So I guess the question is it a replacement or is it maybe a complement?
I would say it's an alternative. As the name says, it doesn't want necessarily to be a super complex, feature full or whatever you want to call it, like a billing engine. It's more like if you need something, I wouldn't say simple, but basic and fast, then you can use the rate cacher. But if you actually need fully flavored billing engine, probably you should go for like CG rates. And I'm just as a note, nobody has anything against third-party solutions in terms of ideally when they're also open source. So it's not like we would like to do everything by ourselves. So we rely on many other projects in order to, let's say, complete the whole ecosystem required by a VoIP solution.
That's as good an answer as any. So I think we'll wrap up questions here. If there's any additional questions, we can save them for later in the day in the summit chat. But I think just like Bogdan said, we're getting started here. We've learned about some really cool stuff we're expecting to see more of. And some people just want to know more right now. That information is going to be coming soon. And let's get our next speaker set up while we chit chat here for a second. I want to remind everyone again that we have a raffle at the end of the day. we'll be giving away a free OpenSIPS t-shirt, one of these. And, wow, out of all of those. And we're going to be giving away 1 hour, mano y mano, with the OpenSIPS team. You'll get to spend an hour talking about just about anything you want. Or like I said before, you can sit and stare at each other. Both are welcome.
Well, hopefully mainly about OpenSIPS.
So without much further ado,
Let me check if the choppy audio problem. Just give me a second.
is it me or is it you?
What that?
Is it me or is it you?
No. It's I'm trying to switch to the presentation mode, and we had the choppiness problem before, so I'm just trying to make sure we don't have it again. So give me a second.
Wow, give him a second. Is Max the only one who lost audio? Is everyone else got audio here?
No, I'm good.
Yeah.
No, I think the problem is with pushing the audio on the YouTube.
Okay, so it's people say it's bad. No. All right, I guess we'll just do it as before.
Come on, Max, don't do this to me.
Latency. It kills everyone.
It's not latency, it's some bugs in the softwares and complex systems. How about now? Is it working?
Everyone hearing us okay? Greetings, humans. Are you here? Tell us. Those of you in the YouTube channel, can you hear us clearly? Choppy?
Yeah, it's, let's wait.
Razvan, sing a tune.
Hello. Yeah.
Razvan, maybe you want to reset your presenting status?
No, it seems good. I think it's okay.
Oh, it's not much better now. We're getting some reports of good audio. Excellent. You are the magic man, Matt.
Yeah, it's good now.
Okay then. Well, without further ado, for a second time, here we go. Razvan, let us know what you got.
Okay, so I was muted when everybody said it's okay. Is it fine now, or?
Yes,
Yes,
it's
we're good to go.
we're good to go.
Okay. Hi everyone. I'm glad to attend this this new OpenSIPS summit. Unfortunately, as Bogdan said, we can't see each other this time, but we can see in person, but we can see each other online. So hopefully this is as closer as possible that we could get. Hopefully in the future we can get closer. Today I will be talking about the new call API we've developed and how you can do call management using it in OpenSIPS 3.1. We will talk about, we'll have a small introduction. I will talk about the architecture from system perspective, as well as the internal architecture, so you can understand how the new call API module works, and why not develop your own modules or your own components. Okay, let's get started. So basically what call API is, it provides means to trigger SIP traffic. So it's an API where you can trigger different commands and it will translate them to SIP traffic for example, for establishing calls, for transferring calls, putting them on hold, and so forth. So it's a simpler method of generating valid SIP traffic for your SIP clients. it provides the logic behind SIP and simplifies everything by simply running a command line or triggering a call, library call. You'll see that it uses advanced in-dialog SIP handling to emulate the behavior of a back-to-back or of an endpoint, but it's not really back-to-back. It's actually 100% SIP proxy compliant, as OpenSIPS is a SIP proxy. In terms of implementation, it's a completely standalone tool. So although it is part of the OpenSIPS environment, let's say, it was not designed to work only with OpenSIPS. It is a standalone tool. It's written in Golang, so it doesn't have anything to do with the OpenSIP code base, let's say. It just provides a few connectors to interact with OpenSIPS. But as I said, it was not necessarily 100% OpenSIPS oriented, but it can also be configured or integrated with different tools, with different other proxies, as long as the interconnection is available. It provides a JSON RPC interface over WebSockets. And there are also some CLI tools available in the project that, in case you don't have like a JSON RPC over WebSocket application ready, you can play around with the CLIs that we've developed and provided in the source code. It has a very modular design. I will talk a bit later about the components that are part of the Call API internal design, but it can be easily extended to support other commands, other behavior than the ones that have already been added. It is very scalable. So scalability was one of the main concerns that we had when we developed this. We want it to be as asynchronous as possible in order to make it scalable. And we are relying on the efficient Go routines. So it's written in a parallel and efficient manner using the internal Golang routines. From the high level design, basically Call API interacts with both the application layer, which is the one that triggers the command, as well as with OpenSIPS, which is the one that issues the SIP traffic towards the SIP user agents on the right. We have a WebSocket over WebSocket connection to the application layer, where the application will trigger commands to the Call API, which will further forward those commands to OpenSIPS. OpenSIPS will do its magic, let's say, and feed back events to the Call API, which are further relayed to the application layer. So basically, in terms of interconnection, we have to provide interconnection with two different types of components. On the application layer, we have WebSockets, which are, we have JSON RPC requests and notifications, which are sent to the Call API through the WebSocket connection. And I'm insisting that there are two different types of let's say, events. Requests are the commands that are triggered from the application layer. But as soon as a request is issued by the application layer, only parameters are validated. So the command itself, like starting the call, is not performed immediately. as soon as the command is received, parameters are validated, and if everything is okay, a reply is sent. So usually the command terminates in less than a couple of milliseconds. Further notifications are then sent back to the application layer in an asynchronous manner using the JSON RPC notification engine. So most of these notifications are asynchronous, so they are sent after the JSON RPC command is answered, and they can come like minutes or a few seconds up to minutes later than the command was actually triggered. So from the application layer, you have to create some sort of JSON RPC session, which consists of the initial request and all the further notifications up until an event ended notification is sent. We decided to use this approach because it was very scalable and it allowed us to create very fast and very decoupled session-like communication between the application layer and the call API. The second interconnection that needs to be done is with OpenSIPS. So again, we have two different directions that we need to communicate with OpenSIPS. One is tell OpenSIPS to do something, and we do that using MI commands. So we trigger an MI command, and that command can be handled synchronous or asynchronous. However, we don't get all the data in the response of that MI command. Most of the data are triggered again, are eventually triggered by OpenSIPS using the event interface. So we rely again on this mechanism to create a decoupled session. We don't want to create sessions or transactions or like long-term transactions between the call API and OpenSIPS. Like we don't want to have different Go routines sending a command and waiting for minutes or seconds for responses from OpenSIPS. Everything has to be as asynchronous as possible, and this was the mechanism that we decided to use. Furthermore, we are using all these using the datagram modules in OpenSIPS, both MI datagram and event datagram. The reason we're doing this is because these are fully asynchronous. Both these modules have fully asynchronous implementations in OpenSIPS. So this means that if I send a message, a request on one interface, I may receive the reply on the other, in a different process. If I were to use something like JSON RPC or MI HTTP module, I would have to use the same process to get the response, but not in the datagram MI implementation where I can receive the response from any other process. Again,
so, let's say that is totally non-blocking. So it's not both at the level of the network and at the level of the application.
That is correct. That is 100% correct. And that was the reason that we designed it like so. Just to make sure it is as synchronous as possible so we can scale it as much as possible. In order to understand how interconnection works, I'm showing you a diagram with different communication between the different external components. So we will study the call start command of the call API. How it works, we have an application here on the left side, which is triggering the call start command using JSON RPC over WebSocket. and it's sending it to the call API. The call API will send the TUSC command instructing OpenSIPS to send an invite, and then it will immediately reply. It will immediately reply before sending the TUSC command, MI command to OpenSIPS. As soon as the command was sent, a notification is triggered to the application saying, hey, the transfer has started. In parallel, OpenSIPS is sending an invite to the SIP caller, and as soon as the SIP caller responds with a 200 OK, then another event is sent back, another JSON RPC notification is sent to the application saying, hey, the caller has answered, or the A party has answered the call. After the event is sent, the call API triggers the call transfer command, which is again asynchronous, which basically sends a refer to the caller, waits for indications that basically the caller will have to send an invite to OpenSIPS, which invite will send further to the callee. And as soon as the 200 OK is received, this event is relayed back to the call API using a different eCall transfer event from the event interface layer, and another event is sent to the application saying, hey, the call has been answered, and there's a missing event on this side saying, okay, now this call start transaction is ended. So the call start transaction is completed. You will see, and I will show you during during the demo, that all these events contain useful information. For example, what is the call ID of the call that remains established between caller and callee, right? We will use this. We will need this call ID in order to perform different other operations on that call. For example, put the call on hold or terminate the call. And again, I will show you how we can do that during the demo. Again, what I want to emphasize is that, and what Giovanni also noticed, everything is very asynchronous. Although it might be a bit complex from the development side, it is very scalable and very production ready, let's say. So it can be easily put in production because we don't really have to have concerns about scalability. In terms of architecture, Call API consists of several components, and I will take each of them one by one and try to present to you what they can do and how they can be, let's say, extended in order to provide more functionality to our Call API. One of the components is the connection component. This component is basically the one that handles the communication with the application layer, but only handles the connectivity, like the networking level. Currently, we have two different implementations of this connection component. One of them is the JSON RPC WebSocket, which is what we will be using now. And there's another, let's say, hidden connection that our call CMD tool uses. And it's basically the lifespan of the connection is it lives as long as the call CMD session lives. Basically, it only lives as long as a call API command is available. As soon as it ended, basically the connection will be terminated. Why I'm insisting about this component is that there was already a question on on YouTube, why did we choose WebSocket over WebRTC? And I'm going to answer it a bit later during the Q&A session. But what I wanted to point out is that if you want to do whatever other implementation or whatever other communication, you can just extend this component, right? So you can have, for example, what do you call it? XML RPC. That's what I was going to say. XML RPC interconnection. If you want that, that's just fine. You simply have to implement two different methods. One is for managing the connection lifetime, and the other is for sending notifications back to the application layer in whatever manner you want to do it. But all you have to do is implement this or extend this connection component. The next component is the CMD component. That's basically triggered when when an application layer wants to use the call API, it will first initiate a connection, network connection to the call API, and then it will send a command. It can, of course, it can issue as many commands as it wants. It can the responses might come in different mixed orders, but that doesn't matter that much because we have a command, and this component is able to manage the lifetime of a triggered command. This command, as I said earlier, you can have multiple parallel commands on a single connection. That is perfectly fine. That is perfectly legit. Again, JSON RPC allows you to do that. That's why that's one of the reasons that we wanted to use it. But again, it might not be the only one. So basically, this component.
Interrupt, Razvan, but it's exactly what Giovanni said before about the scalability. I mean, the ability to actually aggregate multiple commands and responses. Events to the same connection really scales. For example, if you build an web portal with a backend connected to OpenSIPS or anything like this, so basically you don't have to kill your application with thousands of connections to the API just because you want to run thousands of commands.
You could if you want, but you probably don't want that. I totally agree. So it's not a limitation to work only with one connection. It's just that you can have multiple commands through one connection, but you can have as many connections as you want. But as Bogdan said, it's probably not a wise idea to open millions of connections to the call API. You can, for each command that you want to trigger, you can reuse the connection for different commands. Another component is the proxy component. And I was saying earlier that this proxy component was written in such a manner that it doesn't have to necessarily be OpenSIPS, but it currently works with OpenSIPS and it works pretty well. I will show you a bit later during the demo. But if anyone wants to have his own proxy, implement this or use the call API, he will be able to do it as long as he implements the necessary connections. I will present them a bit later. So what this component does is it handles the requests to the proxy, in this case to OpenSIPS, and is able to get the notifications back from the proxy, in this case the event interface notifications. This proxy implements two different components. The ones that trigger the commands towards the proxy, in our case towards OpenSIPS, and the ones that handles the events. And I will talk about these components in the next slides. So in all this environment, OpenSIPS is just one proxy component of the call API. He's the one that implements the SIP logic. He's the one that receives the calls from the call API and translates them to SIP packets and replies and so forth. He also needs to intercept events from OpenSIPS and translate them to notifications, in this case to JSON RPC notifications. So basically what we had to do in order to use OpenSIPS with call API is to create two components, the MI component and the EVI, the event interface component. And we decided to implement them over the datagram, as I said earlier, because it was the most lightweight manner to do it, and because datagram is asynchronous. This allows us to scale as much as we can. I've talked about how call API works and the interfaces that it has and the components it has, and the fact that it communicates with OpenSIPS. And of course, all of these are true, but let's talk about on OpenSIPS side what we have done to make this work. Because although you could have done it before the call-ops module, this module makes things very easy for you. So instead of having to use the transaction module to generate all sorts of messages for call start, call transfer, put the call on hold, and so forth and so on, you can simply use this call-ops module, which basically integrates a lot of logic to perform, integrates a lot of logic that can be used to manipulate ongoing calls. For example, you can, having a started call, you can put it on hold, or you can transfer the call in either attended or unattended scenarios, so both are supported. Moreover, it provides a lot of events that are internally, some of them are internally generated by OpenSIPS, some of them are generated by the user agent clients, but this module aggregates all these events and brings some, let's say, order into them, packs them in an event interface and sends them to the call API. So although, as I said, all the stuff that this module does have already been implemented or could have been implemented in older versions as well. However, this brings a bit of clarity and a bit of order between all those actions and all the events generated. Without this module, it would have been hard, for example, to intercept notifications regarding the transferred call and push them back to the call API. It wouldn't be impossible, but it will be a bit harder. You'll have to have a lot of logic in your OpenSIPS script. So this module simplifies all this. What it does, it basically generates SIP traffic and intercepts the replies for the generated requests, and does some sort of logic. It is very important, as I said earlier, that is not a B2B UA. So everything is done at proxy level without acting as a B2B UA. This brings a lot of scalability in OpenSIPS. The way it does it is it's simply by injecting some in-dialog requests. For example, it will generate re-invites for on hold, for putting calls on hold, or it can also generate refer messages for transferring calls. Again, it intercepts the replies and triggers either success events or failure events based on the replies received by user agent clients. Most of the implementations are done by the module. So simply by inserting it in simply by loading the module in your script. But most of the stuff can also be triggered through MI commands, for example. So you can have your call, and you from MI just say transfer me this call to this particular destination, and everything will and the call the refer will be generated and the call will be transferred. A couple of commands that are available in the call API module is to start a call, to terminate a call, to put a call on hold, to resume a call from on hold, and as I said, the two call blind transfer and call attended transfer to transfer a call or link two different calls together using call attended transfers. Of course, many other commands will probably appear, and we definitely need your help as a community to give us ideas of what kind of commands you are looking for to develop for your application, and why not, for those of you that know the Go language, contribute to the project, as it's fully 100% open source. Here you have a couple of references. So as I said, the call API is a standalone project, is within the OpenSIPS namespace. We have the documentation online. All the commands are documented, as well as the events that they generate. The call-ops module and description about what you can do with it and how it can be used. And there's also a blog that I've written a few weeks, if not months ago, regarding how the new call API can be used to do call management. So check this out and play with it. I will also show you a couple of stuff that can be done, but let me stop my presentation and set it up. Okay, so we had this demo before. We had this layout, like this architecture layout, where we have the application layer, the call API, OpenSIPS, two user agent clients. Well, I've already set this up on my testing machine. I have a virtual machine here in my in the office that is already set up. I have OpenSIPS installed. I have the call API installed and configured. What I'm going to do is, instead of the application layer, I will use a browser. I will use a web interface that will be able to issue WebSocket JSON RPC over WebSocket events to the call API and start a call between two different user agents. I will also use Alice and Bob, which are Alice is basically a limb phone on my computer. Bob is a hard phone next to me here, and I will also use a third. Actually, I will use the call CMD tool. That's part of the call API project. I will use it to transfer a call established between Alice and Bob to a third entity, which is Carol. Here again, another hard phone on my desk.
While Razvan is preparing, I just want to show you that we are really hard working on this kind of scenarios with Alice calls Bob. We actually even have a mug. I'm not sure if you can see it, with an Alice calls Bob mug, right? So it's a SIP mog with the whole scenario we have over here. The SIP
Yeah,
flow.
so that's how we inspired to make
on this side.
API. Okay.
Oh, you have Carol. Okay, okay, that's good.
Who should we have? Sorry.
I mean, a third party. There is a Carol, right?
Yes, it's Carol. It should have been Max, but sorry about that.
But it needed to be Charlie.
Charlie. Well, I like Carol more.
Yeah,
Sorry
him
about
more.
We are very
Razvan
feminist area. We are choosing female characters to our endpoints.
that. Yeah.
Yeah,
I
but
mean-
Charlie can also be female, I think.
Ooh.
Okay, I like Carol
Also
more.
Alex, also Alex.
It's not that I hate Charlie, but Carol is more interesting.
Charlie's watching you. Carol's answering the phone.
Okay, I'm sharing my screen now. Oops. Okay, let me. So, what you should be seeing now, I'm not sure if you do, is a small interface that I've developed during one day. I always start with this because I'm not a web developer and I know that my applications really suck at UI, but trust me, you guys can do this a way better job than me. This was just my few hours experience of putting inputs inside the form. So bear with me. That's all I could do.
Did you use Microsoft Front Page for this? I need to know what your tools are.
No. To be honest, I'm not sure. I'm using Bootstrap. That's all I know. I've used Bootstrap. So here, as I said, I already set up OpenSIPS and call API. If you want me, I can show you here. I have a call API console, which is listening on 10.0.0.227, which is my my virtual machine IP inside my network. Okay, I'm trying here to
Razvan, increase a bit the font just to be sure that everyone. This one, yeah, more, yeah, that should be fine. That's okay.
Let's increase here as well. Okay. Okay, so I have here an SNGrep page, an SNGrep application, which I will use to show you how the call establishes. So let me simply start the call. So I will call from Alice to Bob. Not sure if you can see, but here Alice is calling in my lean phone. So I will answer the call. And now, as soon as I answer the call, Bob is starting to call. So I will answer the second call. Hello, hello. Okay, I can hear myself. Not sure if you can hear, but trust me, this works just fine. Let us see how this works from SIP perspective. So here you will notice an invite was sent by 10.0.0.227, which is my virtual machine. It was looped back to OpenSIPS and relayed further to 10.0.0.12, which is my which is Alice, is my lean phone. It started ringing, and as soon as I answered, the 200 OK was sent back, act, and so forth. As soon as the call was act, a refer was triggered to Bob at summit.opensips.org. Note that this also contains an OS ID. This is the call ID of the dialog. So we use this call ID in order to be able to link the two dialogues together when the second invite comes in. Here you'll notice that the refer was accepted, there was another re-invite putting the call on hold, as you can see here in the trace. And then the second call is this one. There were 2 attempts for not acceptable here. No media was found here and here, but the third leg was answered by my my lean phone. And in this case, as you can see, there's another invite. Sorry, just a second. There's another invite issued from lean phone. What do we see? User
Click hide.
Sorry?
Click hide on the little floater.
Okay.
Where it says stop sharing, click hide next to it.
Okay.
Hide.
Oh, hide. Sorry.
Yay.
Thanks. Awesome. Thank you. Okay. So this is an invite triggered by my lean phone, goes to my proxy, which is relayed further to Bob. Okay. This call was answered, and now the call was established. This one should have been terminated here. So a buy was triggered in order to terminate the initial call. So now I only have a call from Alice to Bob. The same can be seen here on my small web application. For example, what I can do, another operation that I can do is to put the call on hold. Let's do it. Not sure if you can see here on the right side, there's an event that was triggered by the application saying that the call is on hold. Do you see it? Or
Yes,
hopefully,
We do.
hopefully. Let's see how this translates in terms of signaling. So we had here the call answered, and now we see this.
You may want to press C for having coloring by call ID.
Okay.
Again,
Like
okay.
so, or
That's it.
okay. Okay, so you will notice that 2 invites were triggered by OpenSIPS, so by the proxy, which is in the center of this trace. One of them was sent to the caller, one of them to the callee, both of them containing the inactive marker. So basically, the call is now on hold. I can see that on my yield link, so there's an indication that the call is held. And I should be seeing that here. Oh, okay, so this small pause button shows that the call is on hold. I will now resume the call. So the call is resumed. Again, the Bob can be seen here, so because Alice is talking to Bob, and I can hear the call just fine. Another thing that we can do is transfer the call, and I'm using a different console here. I'm using the call CMD tool in order to transfer the call. I want to transfer the caller to the destination SIP carol at summit.opensips.org. All I need to do now is to use the call ID that I want to transfer. In this case, I will copy the call ID from my interface, paste it here. I'm using this CMD tool because I didn't have the time or the knowledge, let's say, to add another button here to do call transfer, input a different destination, and so forth. But it would have been quite the same thing. All you had to do is take the information from the web form, send it to the call API using JSON RPC over WebSocket, and it's basically the same thing. Now I'm triggering the command. All these events are coming, as you can see, are coming. The call is transferring, the call has started, the transfer is pending, and so forth and so on. And you can probably hear my second phone ringing. Answering it. Hello? Hi. I've answered it. I've received a notification that the transfer is successful, as you can see here, and the command has terminated. Okay, let's see how this translates in terms of tracing. So again, after I clicked on hold, there were two other invites that have been triggered by OpenSIPS. This time they no longer have the send receive the invalid marker, so we have only send receive. Calls have been answered. Now you can see that a refer has been triggered towards the caller saying, hey, just refer or call carol@summit.opensips.org. Okay, 200 okay, accepted. The call was again put on hold. Act. There were some notifications saying, hey, we're trying to do that. And as soon as the second call has been answered, a buy was triggered again by OpenSIPS. By the call API, actually it was triggered by the call API, but through OpenSIPS. And here we have the third call where Alice is calling Carol. Okay, call has been answered, and then I hang up the call. Actually, the call was not properly answered. I'd say that Limphone just triggered the buy. Okay, I need to check why. Anyway, it worked. So the call has been properly transferred by my Limphone. So everybody should be happy. So I hope you enjoyed the demo. This was what I wanted to show you. Okay, now the call API tried to end the previous call, which was the call from Alice to Bob, but it no longer exists. That's why we saw those errors. As I said, of course, this demo needs a lot of improvements, and I'm probably not the best guy to do it. But we are looking forward for any help that could be that could come from the community. Okay, thank you very much for attending this this demo. I hope you liked it. Let me know if there are any questions.
There are lots of questions. We're gonna have to trim them down now.
I'm so happy.
Yeah, so you have to give me a beer because I already answered like 3 or 4 on Slack. So while you are presenting, I took care of on the question on Slack. So
thank you very much.
Guy, his hour wasn't enough. He's got to like steal the thunder from everybody else.
Well, he had some audio.
Let's see what is coming from YouTube, Alex, if you can check.
I am, and basically it's the same. What we do have though is the question about the call ops being able to handle refers from MS Teams.
I already answered to that. Mainly no. I mean, they're completely different scenarios.
Okay. And then there was a question from about once both parties are connected together, can we hold, resume such a call in the same manner? Can we inject some other SIP message into this call, like message or info or options, etc.?
Yes, definitely. So basically, it will be a regular call initiated by the user agent client. All we do is just create a call to the phone and ask him to create another call to the real callee. As soon as he does that, we will close the initial calls and it will behave just as a regular SIP proxied call, where we can do whatever we want with it.
Okay, good. There was another question on whether you plan to add events to the call states, such as ringing, answered, etc.
That's a very good question. We don't have that, but we can easily add it. So yeah, just open a feature request, or I will write it down, and it's not that complicated to do it. It just hasn't been done because we didn't think about it.
I'm trying to wrap in my mind around the new API. I will study the documentation, etc. But one possible application for that, but maybe I'm wrong, is solving easily something that normally takes a lot of logic to be solved. And there's, if you think at, let's say, some PBX in the cloud or something like that, you have various levels. You have the phone, the proxy, the media server, or the free switch, asterisk, whatever. Then you can have the RTP, so the media, can go directly between phone and phone, or can pass through RTP proxy or RTP engine, or pass through free switch. So passing through and RTP proxy and then free switch and then come back. So the RTP can be at least in 3 different places. And so, for example, you want to have the RTP flowing locally just to have a lower delay, etc., as much as possible. So stay in the LAN. But then you have music on hold, or you have conference, or you have a refer, etc. So it becomes to be kind of difficult to act on the SDP, on the RTP proxy, and on the media server, on the free switch, to manage the RTP flow at those 3 different levels, and with the interaction through on hold, etc. And it seems to me, I'm not sure, but it seems to me that with this call API, it can be at least a little bit simpler than before to manage this continuous changing of the RTP flow.
Unfortunately, I will have to disappoint you, because no, it won't be that easier with the things to the new call API, but it will be easier with the media exchanger. So yeah, more or less, hopefully I will show you on Friday that you really don't
You guys are giving us so much things to learn and I mean, be enthusiastic about. Super.
Awesome. So there's some sort of another question regarding the why we have used the JSON RPC over WebSocket, and that was because it, according to our research, was both on asynchronous protocol, so you had both requests and notifications, as well as it was easier, it was very efficient and widely used in the web world. Moreover, we thought of people trying to develop other interfaces, and that's why we made it so modular and so easy to add more how do you call them, application interfaces. We will definitely take a look into gRPC or REST APIs. Not sure, however, Flavio, I'm not sure whether those protocols do support both requests and asynchronous notifications. Of course, it doesn't have to be notifications per se, because you can also create a request on the other in the other direction. But for example, from the application layer, in order to receive some notification, if the protocol doesn't support it, you will have to create your own listener and provide it to the Caller API so you can get the notifications back and so forth and so on. I don't have that much expertise with gRPC, but I'm pretty sure REST API is not able to do that.
Because the standard right now for the APIs is REST APIs. And usually when you do the notification, you do it through a webhook. So the most usual way to do it is through a REST API and a webhook to get the notification back. And gRPC is bidirectional. So you have both channels in the protocol.
That's
and
interesting.
there are some API platforms such as API Connect and others where you can proxy a service, but you can proxy a service if it's based on gRPC or REST APIs or SOAP or even MQTT. So it would be interesting to have a standard protocol for an API. JSON, obviously you can do it over WebSockets, but it's not very standard in the API world, in my opinion.
So for example, the JSON JavaScript library that I used was quite easy to integrate because it was already there. Regarding the webhooks, more or less they were a no-go for us, because for a webhook you have to be reachable from like an IP level. It would be very hard from a browser perspective, for example, to get notifications through a REST API. To be honest, I don't know how to do that, but it might be possible.
Let's suppose if I was to build a dialer using the call API, I would love to have REST API and a webhook. So I will push the calls over the REST API and receive the replies and the notifications over a webhook. And on top of that, obviously from a browser is a little bit complicated. But gRPC, I believe it's bidirectional. You could do in both ways using a standard protocol. It's just an idea.
Let's check it. No, thank you very much. That's why it's open source, right? To put as much as knowledge in it as possible.
Razvan, because we are already overflowing a bit, there are some fast question collected by Maxim from YouTube. So there is a question: can we add custom headers when using the call API? I think it's from Gril Galinurov.
Okay, currently not, but that's easily done. So you can do that, at least not from the call API itself. You'll have to code it in OpenSIPS local route script. It's not that hard to do it. It's just not something that we needed. I mean, it's probably just a change in the call API, so any feature request would be easily implemented.
Also from him, it's like a follow-up question: can I modify the invite originated by the call API at the script level?
Definitely, yeah. Using a local route, yeah.
Short question from Maurice Edery: does OpenSIPS CFG needs additional configuration, I guess, for the call API?
It does, and there are basically 5 lines that have to be added. I had a presentation during KluCon. During KluCon, a while back, that shows like the 5 lines that need to be added. Nevertheless, I will provide the configuration script I used for this particular call, so you can see. The blog that I presented also has all the details for configuring OpenSIPS. But again, it's just a matter of loading 3 modules, actually 4 modules, and adding a line for treating in dialog notify messages. That's all.
And a last question. So sorry guys for eventually misspelling your names. I'm not familiar with all the names. From I guess Igit Zorlu. Can you talk a bit more about the potential use cases? I'm not sure exactly what was the context of the question, if it's about cases like commands or whatever. So
Sure. So the idea is that you can do some sort of manipulation of ongoing calls, like starting new calls from using different means than staying in front of your hard phone and dialing a number, like pressing the keys, the phone number. You have tools that you can automatically use. You can develop your own application, as I've shown you in your command line, in your browser, let's say, and just click on a button and start a call. For example, in a call center scenario, you can easily transfer a call to an agent when you see that fit, let's say. Just go in a browser, press a button, and the call will be transferred to an agent. So that's one of scenarios that I'm thinking of right now.
Quick yes or no question. Does it support attended transfer or only blind transfer?
Both of them, both attended and unattended.
Amazing.
Yep.
okay, I think there are like more questions, but we need to. We are already.
The Slack.
We're already late for the next presentation.
Yeah, let's switch. We can continue whatever questions you have for Razvan. Feel free to use the Slack, the Summit chat conference. Also, we can take the questions over there. No worries. Alex, let's switch to the next speaker.
Well. We have our third and last speaker of the day. This is Bram Cappers. He's from AnalyzeData. He's going to be talking to us about real-time SIP fraud detection and prevention, something that every single person on here, I'm sure, has dealt with. So without any further ado, Bram, are you here?
Yes, I'm here. Can you hear me?
We can hear you.
Perfect.
How's everybody on the YouTube channel? Can they hear Bram?
Hey, just give me a second. Bram, can you move your camera a little bit so you're in the smack in the middle of
that we're in the middle
of the picture?
Like this?
Maybe a little bit.
A little bit.
Yeah, that should be cool.
Great, thanks.
How's the audio?
Is the audio
fine?
Okay,
everyone out there?
On YouTube.
Hello. Okay, perfect. Then, then I suggest I start. So thank you, Alex, for the introduction. So welcome, everyone. My name is Bram Cappers. I'm a co-founder of AnalyzeData, where we develop anti-fraud solutions for various applications. And in this presentation, we show you how we actually use OpenSIPS to enable the real-time prevention and detection of SIP fraud. But before we continue with the presentation, there are a few announcements to be made. So in this presentation, we give you a live demo of our fraud detection platform, and we've also installed a honeypot. So for those of you who are interested, you can go to the following IP address on the slide, where you can basically use your own soft phone and start dialing numbers to the platform. Then during the live demo, we can see what kind of traffic has been generated and what we can do further on. So don't worry, the slides and the IP addresses are also shared on the Slack and on the YouTube channel, so that you can also look up this information afterwards. In order for the calls to be considered valid, they have to be specified in E164 format. So in addition, we've also organized a poll where we were really curious to see how the OpenSIPS community is currently suffering from the SIP fraud. We're really wondering what your experience is in this area. So we've actually created a slide for you that's also accessible via the QR code, where you can actually share your experience. And what you will also notice in the presentation are these green boxes, which are references to the questions that we've also put in the survey. For those of you who fill out the poll by the entirety, we also offer you a free fraud detection on a data source of choice. But more about that later on in the presentation. So yeah, I don't have to tell you guys that SIP fraud is a huge issue in this world. And so on average, the financial damage per telco provider per month is estimated at 25K. And we at AnalyzeData believe that this number is simply too big. And we need, our mission, in fact, is to reduce this fraud back to 100 euros. And you may be wondering what our current progress is this far. So far, we managed to reduce 80% of the fraud compared to existing industrial anti-SIP solutions. So the presentation will consist of 3 parts. At first, I will tell you about the technology that we have developed during my PhD in cybersecurity that actually forms the foundation of this anti-fraud platform. After that, Rick Broers, also a familiar face in OpenSIPS, he will also going to tell you how we implemented the OpenSIPS sensor to actually enable the real-time detection of SIP fraud. After which, Josh will present the results and the use case that we presented, we did it to showcase at Destiny, and he will also give the live demo. So during my PhD at Eindhoven University of Technology, my job was to develop new techniques to discover next-generation computer viruses. And so current antivirus software either generated too many false alarms, or they were simply unable to capture these viruses. So I started digging into server logs and into raw network traffic to spot unusual behavior. And there we somehow discovered a way to represent data in such a way that these outliers are spotted instantly. And this enables us to actually go through the data very quickly to find the true problem in there, so that we know exactly which kind of machine learning techniques to use in order to detect the problem automatically. So it turned out that the techniques that we developed did not limit themselves to security, but also could be applied to other domains. So at first, we applied the techniques for the analysis of SIP traffic coming from and to PBXs, where we discovered that there were hackers already trying to get inside the system weeks before the actual fraudulent calls were happening, simply by actually looking for disturbing patterns in the SIP signaling. Another completely different scenario was, for instance, organized by the IEEE, which is the largest affiliation in computer science that organizes events where they basically ask industry and the rest of the world for feedback on a certain data set. So in this case, we received a data set from a wildlife preserve where we actually, where we had to figure out why certain animals were dying. And one of the observations that we discovered was that there was at some stage a truck driving through areas in the park for which he was not allowed to, and eventually responsible for the dumping of chemical waste. The interesting thing about this challenge, however, was that on average, it took teams from six people from industry from all over the world 3 months to discover what has been going on in this data set. And we used with our tooling, and we solved the challenge in just a few hours. So that was really a wake-up call. We had something very interesting in here. So we also applied the system at the university, where we started to study the network traffic. And there we discovered that there were certain users being a victim of ransomware, because we saw some highly disturbing patterns in their in the file access behavior of these users. So luckily, we reported these things back to the university, and they were able to stop the encryption from further escalating. And so you can imagine that these kind of things are very valuable. So we also applied the system, for instance, in healthcare, where we started to analyze patient treatments to see how we can optimize the workflow in the department of a hospital. And so you can imagine these patients, they were diagnosed with cancer. And in fact, we discovered a group of people who did not receive certain treatments that causes their recovery time to be 3 times longer than it actually should have been. And especially for improving healthcare, these are very vital observations. So you can imagine that these results did not go unnoticed. And we've won several awards in different areas, but also were invited to present these results at very prestigious events, including Black Hat USA and also Still Hacking Anyway. So in addition, we were also invited so every year to share our recent developments in fraud detection in international reports, such as the European Cybersecurity Perspectives. So for those of you who are interested in the articles, I've made some shared links on the slides, which we'll also make available after the presentation. And so the thing was that we applied the fraud detection techniques in many different domains, but we noticed that especially in SIP, the need for anti-fraud solutions was simply by far the most. So that's why we decided to focus in this area. If you would already open up the Europol reports, then you can see that the financial damage estimated last year was already in the billions of euros, indicating the seriousness of the problem. And we're not the only one who've been talking about this topic. Also, Flavio, one of the OpenSIPS pioneers, already gave a talk at Astricon where he already indicated the value and need for anti-fraud solutions in SIP. So how is it then that we do things differently? So basically, so many traditional anti-fraud solutions, they focus on the analysis of call detail records. But there are several disadvantages to the approach. At first, CDR records are all generated after a call has been made. So even though you can detect that a call is fraudulent, then basically you're already too late. The money is already gone. And in addition, the only way that you can actually prevent the fraud from happening is by blocking that entire user, which also means that the regular traffic of this user becomes impossible until after investigation. So we actually discovered that in many cases, the fraud could actually already be discovered at a very early stage during the establishment of the call. So that's why we decided to analyze data to analyze the full life cycle of a call using SIP analysis and by studying the SIP signaling packets. So, and there we actually are able to, even when we already discover that a call is fraudulent, we can already early stage block the call to prevent the fraud from escalating. And in addition, you do not have to block any users anymore because we can, on a call level, on a per call basis, decide which ones are the bad ones and which ones are the good ones, so that the user can always stay online. And so over the we have already developed quite a number of modules to support a wide range of SIP fraud, including Wangiri and also international revenue sharing. And it is because of our core technology developed at the university that we were able to very quickly develop new modules in case of very domain-specific fraud or upcoming fraud. So we also use, and so the reports that the incidents that we report are coming from different types of severities, and we use advanced clustering techniques to make sure that these incidents are only reported once. So the thing is that because we know exactly which type of machine learning techniques to use, that our false positive rates are very low. So typically, we generate one false alarm every 2.5 million calls, which is roughly 100 times better currently than industry standards. So how does the system basically work? And so we have a SIP traffic that is being captured by OpenSIPS and is being sent into events that can be analyzed by AnalyzeData. And besides OpenSIPS, we also provide support for other types of SDKs, common for instance for PHP and JavaScript. So the incidents can be inspected via a front-end interface, but alternatively, you can also decide to receive them by text messaging, mailing, Slack, or generic webhooks. So the moment these incidents arrive at the operator, he can decide indeed whether these incidents are indeed fraudulent, after which the information is returned to AnalyzeData so that we know how to adjust our models to prevent false alarms from happening. So basically, there are different types of ways to integrate with the system. So one of the more common approaches and an out-of-line solution is by mirroring your SIP traffic through the OpenSIP sensor that in turn uses a REST API to forward the events to AnalyzeData. And so AnalyzeData in turn can then generate the alerts and send them to the operator, after which he can decide what to do next. If you want to enable, for instance, the live blocking of calls, there is also a synchronous solution, and where the events are also sent via a REST API, but are guaranteed to return within a certain amount of latency, so that the OpenSIP sensor can then in turn decide whether to forward the call or to return it back to the call source. And so although that these first two integration steps are fairly generic, there's even another way that we can do in SIP to make it even more efficient. And that's by configuring AnalyzeData as another SIP endpoint. So basically, this way of integration is simply adding an entry to your routing table, which means that the SIP the traffic is first routed to AnalyzeData, after which we can perform the analysis. And then if we consider the fraud to be fraudulent, we return a 603. That in turn can be routed back to the call source, or we can use a 503 to indicate whether a call is normal. After which then the OpenSIPS as a soft switch knows that it has to route the traffic to the next destination. So the nice thing about this way of integrating is that you do not have to mirror your traffic, which can be very expensive. And you also do not have to install any probes, but we can simply, by adding an entry in your routing table, make sure that your traffic gets directly and as efficiently as possible to the sensor. So this was my part of the presentation. Rick will now continue on the development of the OpenSIP sensor and the showcase that we used at Destiny.
Good afternoon, everyone. So yeah, I'm going to tell you about what we exactly did with OpenSIPS in this setup with AnalyzeData. I was on the Destiny side of things, of configuring, seeing how the first version of it would work and function. We put a lot of calls through it. So what did our setup look like? We already have an IDS in place, traditional IDS based on CDRs. Next to that, all of our, to start with, all of our traffic of our SIP traffic is basically within a VMware. So within VMware, you have the possibility to easily mirror your traffic to separate nodes, which meant that we had to install on every of our VMware machines, we had to install a probe. But first, obviously, we started with one, and that already came into some problems. And I think Bogdan and Livio both had some contributions to fixing it. But okay, back to our use case. OpenSIPS was in the mirror setup. It basically receives all of the invites, all of the SIP traffic being mirrored from our VMware environment. And from there on out is being put over a HTTP connection towards AnalyzeData, HTTPS even, because we don't want anyone listening in on our traffic, obviously. From there on out, we went to compare the results between AnalyzeData hits and our own hits based on IDS. I think you've found nearly all of the fraud that our IDS also found. I think you found all of the fraud even that our ADS found. But more on that later. So regarding the OpenSIPs, how does it work inside the OpenSIPs? At the moment we were testing that there were two versions. We had, I think, a freshly released 3.0 at the time, and 2.4.6, which was more of the main branch at that point. I don't know if you've already switched to 3.0 as your main branch at that point. But we tried both. Why did we try both? Because in both we came across a different bug, which made that we couldn't continue any further. What did we try to do? We got all of the traffic on an OpenSIPS, which was basically listening on an open Ethernet port on its VM. And SIP capture module, which enables OpenSIPS to listen in promiscuous mode, so it can read all the traffic. So every invite which was sent into the machine was then being able to be processed by OpenSIPS, which in turn allowed us to extract all of the information from the invites, ACKs, cancels, all of the messages you want to inspect, and throw it over to AnalyzeData over the REST interface. And then at the end of the script processing, we simply drop the message, because obviously as we are in promiscuous, we don't want to respond to any kind of message. So to get that to work, I think we first tried it on version 2.4.6. And well, this is some snippet from, we really load a minimum set of modules. I hope it's all readable, it should be. And this is basically the main body of the script that we've been using. You can see there's 3 dots here, obviously indicating that there's more of the same. So we're checking for a method, and from then on out, we're going to build together a JSON packet with all of the parameters which we are interested in, or of which AnalyzeData is interested in. And at the end, we do a REST pose towards their endpoint with the JSON, and we wait for the reply on, which we can then report on in the logs or something. Put a simple xlog, and then you can see what the response is of AnalyzeData. So on 3.0, what happened on version 3.0? We had, I think, a bug which hit immediately as soon as the first packet would arrive on the interface. It was related to the SIP capture module. And I think Bogdan fixed it in about 10 to 12 days. But the other issue, which we had on 2.4.6, I think was even fixed earlier by, I'm not sure if it was Razvan or Livio, one of the two. But he saved the day by fixing a bug in the REST client, where we also had a crash. Yeah, as you can see in its sync, I'm not that much of a developer myself, but yeah, it had something to do with initializing something, which didn't happen in this case because we were running one of the unique cases, such as Bogdan mentioned in his first presentation. So yeah, we found both of these bugs. We reported them both, and they were both fixed, I think, within 10 days. So that was a very good experience. And eventually we went on with the 2.4.6 branch because that was that had the quickest response, and we could also fix it ourselves. We did a small little patch on the code. yeah, and then it's my time to turn over the mic towards my colleague, Josh Mangerink, who is going to also give us a small demo. So if you have a small minute, then he'll be ready for you. Thank you very much.
Yeah. So let's see if I have, you didn't mute it, did you? No, it's still muted. So good afternoon. Yeah, it's still afternoon. So my name is Josh, and I'm one of the co-founders here at AnalyzeData, mostly responsible for development and engineering. So yeah, to get back to what Rick said about the results that we did. So comparing our results of this sensor and using our machine learning and AI techniques to analyze the SIP traffic in response to the traditional IDS used at our pilot customer, we found that we block 92% less call minutes invalidly. So this is calls that get blocked due to some rule-based intrusion detection system that should not have been blocked. So imagine a conference call, 20 people call in, and there's a large amount of cash going into that call, but it's a legitimate call. And a rule-based approach would immediately invalidate that call, whereas our machine learning is able to actually circumvent that. And also, in addition to the regular IDS that was also already in place, we managed to find 80% more fraud, so saving quite a lot of money for the company. So our biggest achievement there was that we actually found a hack that the real IDS only spotted 3 months later. So we were in an out-of-line solution, and at some point they said, "Oh, hey, why was this not signaled this month?" Yeah, because it was already signaled 3 months ago. So that was really one of our biggest achievements. So the nice thing in this use case is that we were able to reduce the average damage of a fraud case to 6 cents rather than thousands of euros, which it is normally. So that was a great achievement, really. So let me, because that's what I'm here for, let me give you a quick demo of what we've been doing. So I wanted to see, so there's 2 things I'm going to be demoing to you. So one of the things, as Bram already mentioned, is that we set up a honeypot this weekend to just see, like, hey, how cool is it if we can actually do a live demo? So let's hope that the demo effect does not kick in and it all works. So I'm first going to be showing you some of the results that we got just over this weekend, just over the amount of random hacks. I think we set up our honeypot, and I think it took all of 10 minutes before we started getting spammed with fake registers and fake invites. So that was quite, I thought they were quite fast at that. And secondly, just to make sure that we actually show you some interesting stuff, we'll be going into one of our existing demo projects that already has been pre-populated with some data. So let's see about the honeypot. So what we see here is a quick overview of incidents. So what are incidents? Incidents are basically clusters of calls that we mark as fraudulent. So if a call comes in, we can mark it either as safe or fraudulent. And if there are a lot of calls that are highly similar, we group them together in an incident to make sure that it's understandable. So up top here, you see how heavy the incidents are over time. So this is yesterday when we spun up our honeypot, and you see there are apparently almost 5,000 fake registers fired towards that honeypot. So this allows for zooming. There's not really a lot to zoom. We'll see a little bit of that in a bit. So let's just get right into it here. So here we have a bunch of incidents that have been reported by our platform. You see at what moment in time did the hack attempt start? At what moment was it did we detect the last event in this incident? What was the estimated amount of fraud that we think we could have countered in this sense?
I think we are not seeing your screen.
You're not seeing the entire screen, or?
We're stuck on a screen with the demo.
Sorry? You're still seeing the slides. Okay.
Let's
see if I can reshare. Share my entire screen. This one, share. Okay, hang on. I think this is going to be bad again. Is this better?
Yes.
Yep.
So now you should have 2 windows, one saying demo 2019 and one saying OpenSIPS demo.
Right.
You're on.
Yeah, all right, awesome. All right, so quickly to recap, because you had the voiceover, 2 demos, the OpenSIPS demo of the honeypot that we've had up this weekend, and then let's actually dive into some actual data. So is my cursor visible, by the way? If I'm getting feedback from you guys anyway?
It is.
Okay, great. That's awesome. And now I can't see you guys anymore, so that's kind of shitty. There you are. All right, so again, incidents. So here you see a number of incidents that our platform has detected. from a particular user. Right now, because we don't really have usernames or stuff in this fake online environment, we're just using IP source combination, IP port combinations. You see the number of calls that we've grouped into that incident, the severity. So we work with a traffic light signal where it's either green, yellow, or red. Then you can see what sources are involved. Most of our platform, well, pretty much all of our platform, and also the honeypot works in an anonymized setting. So that's why you're not seeing entire numbers, but anonymized numbers. So here you see that it's like pretty fake stuff, like 4-digit numbers, 1111, 2222, 333, etc.
Sorry to interrupt. If that's a web interface, maybe you can increase the font a bit. It will help.
This better for you?
Yeah. Okay.
Okay, so it's going to be smaller. Let me see. Is this still acceptable? Because if I go too small, it'll start going into tablet and mobile mode, and then we're going to drop columns.
It's acceptable at this stage.
Okay, good. I can try. I'll explain a little bit, and I'll zoom in so it's a bit bigger even still. So it'll tell you just something about the incident, and then I guess really the most interesting stuff is what's happening in the back. So we're giving like a short summary of why do we think that this is actually an incident of fraudulent calls. So in this case, one of our algorithms has suggested that this is potential bot activity. So what you're usually going to see is a large spike in activity rather than just some regular normal curvature like real large spikes. We'll see that in a bit as well. And we've also detected that these are not actual phone numbers being dialed. So in this case, 1111 is not a valid source number. And you see that this is probably most likely the same attacker, because like all of these numbers and all of these incidents are the same. So let's open one up and let's see what we do. And I can probably zoom a little bit more for you guys. So up top is the summary of what have we analyzed. So as Dek was already saying, there's a bunch of stuff that we receive from OpenSIPS. So there's message IDs, there's display names from URIs. So all of this stuff should be pretty familiar to you guys. So yeah, so here indeed we see that this is a friendly scanner, which makes a lot of sense, right? So it's a scanner and then just scanning, well, pretty much like on what ports are we open at all? So yeah, that makes sense that we have such a large amount of similar activity going on. We get a summary of how far did the call go. So in this case, they're just pumping registers to us. So the call does not advance. Normally here you would see actually the stages of the call going from registered to trying to answer to buy, all this kind of stuff we'll see in a little bit. And this call or this packet was marked by our AI as being suspicious. And then below, we'll see this in a little bit more detail in the second part. We'll actually have an explanation of the different algorithms, because we use a large variety of why our algorithms actually triggered this as being fraudulent. Now, for all these registers, it's not that interesting. It's mostly large spikes in activity and invalid numbers, and you'll see that it's the same for all of them. So let's, to make it interesting, go to actually some of our pre-populated data to actually see some more interesting stuff. And you'll see that probably now, because we're streaming, the demo effect's going to take effect and my internet's going to crash. So there it is. So here you see a 4-month period of time over which we've done fraud analysis. It reaches from January to like April. And you have the intensity, like at what point in time did you receive how many alerts from our platform? So this helps admins just focus and zoom in on particular parts. So here you see, for example, that week 13 was a particularly high activity week with almost 3,000 fraudulent calls. And we estimate that this is almost 4,000 euros worth in damage in this week alone. So once we have this stuff, again, here you see a little bit more variety of the different types of algorithms that we use. So again, bot activity, high amounts of premium number dialing, stuff like you are dialing countries that you're normally not dialing, you're dialing at weird moments in time. All of this kind of stuff. So let me just open up really the first major one.
If I may push a question here.
Yeah,
okay, you say your algorithm identified like a potentially dangerous destination or a potentially, let's say, wrong time of day. Do you pre-configure this? Do you have kind of a profile saying, okay, yes, for this caller, you know, this time window, it's the okay one or not, or which are the, you know, the allowed, or
so let me open
not
up
triggering destinations or stuff like that?
Yeah, so let me open up this activity, and I think that'll immediately answer your question. I'll scroll straight down. And so one of our activities, or one of our algorithms indeed analyzes what time is it normal for this user to be active, right? And so this makes a lot of sense. This looks a lot like a business phone, like they start dialing at 7 o'clock in the morning and they probably end at like 6, 7 o'clock at night, 5 days a week and not on the weekends, right? This makes a lot of sense. This is kind of like expected behavior. And as you're saying here, we have a profile of like, what is the expected activity for this user that we've learned? And for this particular call, it's a Tuesday night at 10:15 in the evening. And you see, like, this is so unlikely. Like, this person never calls in the evenings, and all of a sudden they're calling in the evenings. Moreover, it's not like they're just calling in the evenings. Here we see the number of calls this user is making that we've marked as fraudulent before, right? So we see enormous spikes over the past couple of days of this user doing suspicious stuff, right? So that makes other calls that are already a little bit suspicious more suspicious because they're happening in large clusters. And actually, your second question was with respect to countries and destinations. So let me quickly, I have to zoom out a little bit now. Let me find actually a very interesting user with respect to countries. I'll zoom in a little bit again. To cooperate, yes. So the data again that we're analyzing here is very faint, right? So we have a time, at what time was the call active, was the call done, from what was the source number of the call, what was the destination of the number of the call. Again, our algorithms function even under anonymization, which is really cool. So you can probably really quickly see how this information can be extracted already at an invite, like a register invite stage. And here you see these dispositions that I was talking about earlier. So at some point in time, this call was trying, already 2 seconds later it was answered. And this was so quickly on. This is something that we also analyze. So you see that over time, our traffic light signal may actually change. So the simple fact that a call is answered might already make it more suspicious. The speed at which a call is answered might make it more suspicious. So your question was with respect to profiling of call destinations. So here we see the profile of this user of their call destinations. And well, since we're doing it semi-interactively now, Bogdan, so how about you tell me whether you can see something suspicious in this graph?
Well, besides the color over there.
Yeah, exactly.
Like, right. So what you are saying that in terms of destination and also, let's say, time pattern, everything it's like learned data.
Yes.
There is nothing pre-configured.
No.
You just give a time your software to gather and crunch data and say, okay, that should be the user profile in terms where and when it calls.
Well, yeah, so actually we do both. So there's a couple of, how do you say, there are a couple of things about SIP signaling that are at some point so blatant that it's so easy to say, yeah, this is just plain wrong. Like at some point, if you have a user and they fire 100,000 failed registers for a user ID, and then attempt 100,001 is successful. Yeah, we don't have to learn anything. Like that's a brute force. We're seeing immediately that's a brute force. We're blocking it. But so in this case, indeed, it's learned. Like if you see this is a user, we're a Netherlands-based company, so you see that the Netherlands traffic, this is pretty much like 99% of what they're doing. So if we like disable this regular behavior, we immediately see, all right, there's something really suspicious going on here. Like at some point, this guy, for months and months on end, they're just dialing Dutch numbers, and all of a sudden they're dialing God knows how many numbers. I don't know how knows how many destinations. Oh, and I think I zoomed a little bit too much there. So I need to reset. So actually, if you zoom into this particular case a little bit more detail, you'll see that this actually takes place into like 3 or 4 hours. So the probability that they're just always only calling the Netherlands and like matching their volume in 2 hours to like God knows how many destinations, our algorithms determine that that's super unlikely. So
just quick for you, if I may. How do you determine those activity cycles? Are you using like some kind of FFT transfer, or what is
I'm sorry, I didn't quite get your question. Sorry.
I mean, for the activity cycles of the user, is it something that your system learns?
So this, you mean these graphs? Like, yeah. So this is something that we actually learn over time. So we have a learning period of approximately 2 weeks, and then we use a variety of machine learning algorithms to actually determine like what is part of your regular behavior and what is not. If that answers your question.
Yeah, it is.
Yeah, right.
There is also a question about from Oliver. He asks to point to the website. I don't know. Apparently, somebody could not find your website.
The
URL for AnalyzeData.
Oh, it's analyzedata.com, but with a Z.
Just like in the presentation header, guys.
Yes, exactly. If that's not working, then it's probably because you're DOSing it. No, just kidding, just kidding. So yeah, it's like after this presentation, if you guys have any further questions, just like please just jot them down and we'll get back to you in the Slack. But also feel free to like just keep them coming. Like we're very comfortable answering stuff in line. So with respect to this call graph, like visualization is a big part of what we do, trying to just make it easy for operators to determine like, is this fraud? Is this not fraud? And if it's not fraud, to feed it back into our machine learning algorithms so that we can make our decision making even better. So here you see it quite regularly, like pretty much all of their frequency, dark blue, is centered on the Netherlands. And so there's a bunch of really weird traffic going on to all sorts of places. Like normally we'll see that there's a source will call stuff that's in the vicinity, right? Like a US-based number will call mostly North and South America. An EU-based number will call mostly mainland Europe, et cetera, et cetera. So already stuff that goes beyond borders is beyond continental borders is really weird. So this is quite a blatant one where it's just all over the place. Let's see, what else can we?
There was a quick question here. The profiling, is it only user-based?
So actually, our profiling is configurable. So you can do profiling on a caller level. You can do profiling on a server level. You can do profiling on a trunk level. So it's really configurable. You tell us on what level you want us to profile the stuff. We can also do all of it or none of it, of course, but preferably some of it. But yeah, so it's configurable. And so in this use case, we are working on the trunk level. So every trunk, so every customer that is actually porting stuff into our OpenSIPS platform, we're profiling per customer, basically. So that's why you'll probably see some differences. So let's see if I can actually show that to you. So again, as said, so here you will see a user that has a very nice 5 working days. There might also be users where you'll see less high peaks, but they go on for 7 days, which is then clearly really like a consumer phone. You'll see different types of behavioral clusters, let's call it that way. So one of the things that we are working on currently is actually, can we cluster users into different types of users, like business phones, consumer phones, real trunks, and that type of stuff. So I guess that's pretty much all I have to show you. I mean, we can do more examples if you guys like that, or we can just open it up for questions.
We have some questions that were kind of like lagged on here. Does it, on the SIP level, are you guys analyzing things like transferred calls as well?
So I'm not that big of the SIP guru. I must. Do you guys have audio? You guys don't have audio, probably, right? All right. So can you repose your question and then I'll fire it into the group here?
The question was, does the at the SIP layer, is it tracking or including analysis on transferred calls?
So the question is, on the SIP layer, do we include transferred calls? So if I understand your question correctly, I'm going to try and answer. Maybe these guys can point out some errors on my side. So transferring is if when you have a multi-leg call. That's your question, I guess, right? Or is that
pretty much?
Yeah. So we have some infrastructure in place that will actually try to correlate if you have multi-leg calls and you're not giving us a proper correlation yourself, that we actually try and correlate different phases of the call. At a current stage, this is best effort, because sometimes with concurrency, this is really hard to do. I guess that pretty much covers it, right? Yeah.
Yeah, in the OpenSIPS level, you have the invite, which is being sent into your platform, and a transfer mainly also works with invite, re-invites. There's some different mechanisms, but I mainly think these are used.
Yeah, exactly.
So you have basically all of them.
Yeah,
and
exactly.
you correlate them then probably together.
Yes, yes. So in this use case, it's really nice because they already have a correlation mechanism in place where they will, if they transfer the call, they will give you the call ID of the previous call that they're transferring. So we're able to as breadcrumbs, like it's a breadcrumb trail, and we're able to reverse engineer the breadcrumb trail. But yeah, so we do that partially, yes.
I have a question regarding the. You mentioned some detection algorithms. Are those already hard coded? Is there some sort of language that can be used to define your own, let's say, detection algorithm?
So at present, we have only, well, hard-coded is a bit of an overstatement maybe. We have predefined analyzers, yes. So we have approximately 25 algorithms, and you can choose which ones yes or no you want. So some of them are privacy technically more intrusive than others. So for example, you might not want to give us the countries, right? The source and destination countries. So you might want to give us geo coordinates or not. So depending on the types of additional metadata that you give us, we're able to do better or worse types of algorithms in terms of detection. Our platform is configured in such a way that it should be doable to add user-defined anomaly detection. So at present, all of our algorithms have these learning parameters, but they're also user configurable. So there is, in that sense, nothing that would stop you if, for example, you want to define a threshold-based rule, you can define that. So it's not out of the box yet, but it is supported in the backend infrastructure, yes.
I have a question.
Yes. There's so many different places, and it's hard to keep track of who's asking questions. Please.
Hello, Vasilios. So I saw in the previous slides, what is the average latency exposed for the inline solution?
So it varies. So to answer your question, it depends on how many services you have active. So if you want our full suite of analyses, you're looking at between 150 to 200 milliseconds. If you want an optimal set, so there's a couple of ones that take really long. And if you exclude those, then we are usually sub 100. So the baseline set is actually at like between 30 and 40 ms. And if you start including more heavy profilers, so if you want like a 60-70% catch rate, then you're looking at this 50 ms range. If you want to go up to 80%, then you're looking at a 100 ms. If you want to go beyond 80% catch rate, like to 90-95, then you're looking at 150 to 200.
So if we limit it on per destination, for example, and let's say 90%, so it's low as a kind.
You have a lot of echo. I'm having quite a hard time to understand your question. I'm sorry. Could you repeat?
So if we limit by destination only, for example, that would be lower, right?
Yes. So indeed, like you could tailor the stream that you feed us so that you don't want all algorithms. It's even in that sense possible that you do a multi-staged approach in which we do a preliminary analysis where you say, for example, okay, I want a risk score based on only a couple of algorithms. And if this one says, okay, like 100% safe, fine, let it pass. If it's not 100% safe, say you get like a preliminary threat score of say 50%, then you might choose to incur another 100 ms and do another round trip with a more heavy check.
Okay, and another one, do you support importing CDRs?
Yes,
So your platform can learn quickly?
Yes, so that is an excellent question. So indeed, so that is like the main difference that I failed to mention to you guys. So this OpenSIPS demo is like live right now. It's coming from an OpenSIPS that's running right now. And this demo is actually imported from CDRs. So what is happening in the back of our stuff is that what we're trying to do with this live OpenSIPS integration is we're partially emulating the CDR. So as CDR information becomes available to us, we're augmenting it in our database and rerunning the analysis on that augmented CDR. So you can imagine that, for example, in a completed call, so it's not included in this example, for example, the billing information, which is a really good indicator of how fraudulent is a call. It's not available to you like as the call is being set up, but it is available to you usually after termination. So in that sense, like once that information becomes available in our virtual CDR, we're able to go back and feed that back into our machine learning algorithm.
Okay, thank you.
Great.
Can I ask a few questions of you?
Yeah, sure. Like I think Bogdan is keeping track of time, right? So
you have a lot of presentation. Don't you worry about it.
Shoot.
So, first of all, why are you using SIP mirroring and not app protocol for SIP capturing as it was meant for those purposes? Why are you want to mirroring the SIP traffic and not just get the app to do the asynchronical analyzing?
So the question, I'm going to forward this to you probably. So the question is, why are we using? Sorry.
Yeah, just to drop in a bit, because I was about to ask more or less the same question. There are two different things. So first, from the, let's say, from the actual, when you are not inline mode for the actual platform, you do mirror the full SIP to the OpenSIPs, which extracts data, and then you do the REST query. And I think Shlomi's question is, why do you use this kind of a custom REST query, which extracts kind of a metadata from the SIP package in order to send it to the AnalyzeData, when you could also use the existing HAP protocol to get these metadata from OpenSIPs to AnalyzeData. So it's for the lag between the OpenSIPs and AnalyzeData. And I'm not sure if the HAP covers everything, but an advantage would be then automatically there are a lot of SIP entities, SIP applications which are already implementing HAP, for other purposes, but it's there.
So the response I have is quite a bad one there. So the question is, why are we using this integration rather than the HEP integration that they also offer? So I believe that this is kind of like a legacy kind of thing that we started developing this, and then the 2.4.6 version where we had a bug with the mod promiscuous. Then I think that was the reason why at some point we started fiddling around in 3.0 and we couldn't get it to compile there back then, I believe. So this is something that the HAP solution is something that is very high on our Christmas list. We really want to, indeed, like you say, to make this integration, but it's like a legacy thing that we're still not supporting it that way. But it is, again, it's high on our Christmas list.
Good. So after Bogdan stole my first one, I will have another one. Would you consider, or are you working on when doing asynchronical monitoring? So don't delay the call, but if we see that we let a malicious call come in, then ending it up with the great call API that we were all introduced today.
Yes, exactly. So, so as my colleague mentioned, we offer two kinds of integration. So one is synchronous and one is asynchronous. So the asynchronous one will actually give you a callback, and then the end user, like our customer. So we don't manage the OpenSIP servers ourselves, right? Our customers do. And in that sense, the customer from this webhook is then indeed free, as you say, to terminate that call. Actually, we recommend this. So the reason why we offer this asynchronous variant is that it's usually quite scary for new customers to say, sure, be in line, be in the critical path of my application, and actually block calls for me. They want this two-phased approach where, yes, we're alerting them, we're giving them the button to press, but they want to be the one that actually presses the button to kill the call. So one of the future things that we're indeed envisioning is actually to take this API integration and merge it into our platform. That's so when you're actually in this alert overview, you'll actually get a big red button saying, okay, actually go and fire at OpenSIPs and make OpenSIPs terminate this call for me, like live there from the dashboard. So yes, we are definitely considering this. And again, this is on our Christmas list, but maybe not quite as high as HEP, but it's still on the Christmas list.
Thank you very much. Thank you.
Great. Thank you for the question.
Looks like a great product.
Thank you. Are there more questions? So I think we have like
there was another question from Gary. He was wondering what type of deployments you support on site or in the cloud.
So at present, all of our stuff is in the cloud. It's Kubernetes based. So we do intend to start supporting on-site deployments. Because, so again, it's Kubernetes based, right? So as long as you run a Kubernetes cluster, you're able to deploy to your Kubernetes cluster. So I'm being okay. So
we can do a quick question here. Morris is saying that the OpenSIPS fraud detect module works great, detects based attempts and call duration, and rejects calls detected as fraud. So no call will complete, but those allowed on fraud detect table. Maybe he's asking if there's some type of integration possible with the fraud detect module.
so I'm kind of going out on, so I have to forward this one to you guys again. So they're asking whether, how well we integrate with the OpenSIPS integrated fraud detection module. So in that sense, so again, I'm going to look at you guys.
At this point, we didn't look into the fraud detection as we mainly wanted to get traffic into the AnalyzeData platform. Obviously, this could go together. You could make a multi-layer approach with fraud detect module from OpenSIPS together with AnalyzeData solution or your self-developed or other external IDS. You can layer all of those approaches, I think.
But so in your question is, are we integrated with that module natively? No, we are not. So that might be something for us to definitely consider.
They are, even if, on a first look, they are, in terms of purpose, quite similar. I would say there are some radical differences between the two. First of all, it's about how you define what is a fraud or not. With the fraud detection module in OpenSIPS, you create profiles and you put like basically static data. What
right.
means,
it's mostly rule based, I think, right? From
yeah, it's not necessarily because it's rule, but you have to populate it by basically to upload such information, like what means illegal destination, or what means too much traffic and stuff like that. So it's not learning based on the user dialing pattern. So
one of the things, if I sorry for interrupting you. So one of the things that we are investigating is, because again, we're like, our anti-fraud is broad. Some of the stuff that we're doing in other areas is where we actually integrate in that sense with those existing anti-fraud solutions by populating rules like that. So one of the things you might imagine is indeed, like, once you've learned a profile, that we from the dashboard can automatically populate your OpenSIPS fraud detection module with these rules, like, okay, these are destinations. Once these euro thresholds hit, when you see this, then start blocking in line. That is definitely a possibility. If I may still, like, before, probably there's more questions, and like, again, if there are questions, like, please drop them in the Slack. We'll try to get back to all of you. I want to just continue my 2 slides before I get before I get yelled at for forgetting to do 2 slides. So one of the things that we're doing indeed is trying to tackle is SIP fraud, but there's a bunch of stuff that we're struggling with as well as a startup. So one of the major things is finding people who like larger companies that want to try our solution and actually see, like, okay, can we also, in a bigger context rather than our small pilot customers, can we detect fraud and counter fraud there accurately? So this is kind of like a shout out, like, if you are working at a company who is struggling with fraud, like, please hit us up and let's see if we can do something together. So we have a survey with a bunch of questions that we set out. So I'd like to point out to that again, with a bunch of stuff that we want to know from you as an OpenSIPS community, as people working in the SIP community. What are your opinions on this? What do you think about this? Are we on the right track? Are we not on the right track? One of the things that we're struggling with is that we have all these algorithms. We're spending a bunch of time on this. Like, what is a reasonable pricing model for us? Is it like one-off? Is there is it viable to do like volume-based pricing? Like, I'm not sure how familiar you guys are with Sentry, but it's like, okay, we ship stuff to you, and for like a minor, like a thousandth of a cent per call, we'll tell you whether it's fraudulent or not. Is that stuff you would consider? So we would really, really appreciate it if you guys would fill out our survey and questionnaire. And for the people that do, again, we are willing to analyze the 3 months of your CDR for free, just to see, like, okay, how much fraud are you actually suffering? Like, so if this is something that you're struggling with and just wondering, like, okay, how well is my fraud detection doing? Do I even have fraud? Like, if you're interested in that, hit us up. If you fill out the questionnaire, we'll do 3 months of analysis for you for free.
It's like 4 billion CDRs.
Sorry? So yeah, so one of the ways.
4 billion CDRs.
I'm sorry, you dropped out for me. Could you repeat the question?
Sorry, like 14 billion CDRs.
Yeah, 14 billion is a little bit much, maybe, but sure, we can always try. Like, we'd be really interested in seeing how far we get, actually, to see how scalable this solution is. So one of the things that we're able to do, we're either able to do 3 months real time or like a one-off CDR. So 14 billion might be a bit much. We can always try and see how far we get. But yeah, so again, we'd really appreciate any feedback you guys have on this.
That's about 15 minutes of Max's like platform. You know that, right?
I don't know, but yeah, we'd be interested. So like, even if we don't do the entire platform for a while, maybe we should like rephrase it and say, okay, it's not 3 months for you, it's 5 minutes, but we'll see. like definitely, if you're interested in this, please hit us up. Like, we'd be interested, really.
No, absolutely. We'll talk.
Awesome.
I think you're going to get a lot of queries from a lot of people that were here today.
Yeah, please. So we're actually looking at the Google form live, and we're already seeing like a couple of questionnaire entries coming in. So thank you guys very much for those that are filling that out right now. Definitely. Sorry for interrupting you.
No, that's it. Are you guys, that's the end of the presentation?
Yeah, so these are my slides. So yeah, if you guys have any other questions, I think I have 1 minute, so that's a bit short. But again, like if it's not here, please feel free to hit us up on the Slack, and we'll try to respond to as much as you as we can.
Live questions, anyone? Use the YouTube or the Slack channel. We're warming up the AI for the raffle.
All right, if not, then I'd really like to thank all of you guys for doing such a great job on organizing a digital conference. We were really looking forward to see all of you guys in Amsterdam, but unfortunately not. But I guess as far as Corona-based stuff goes, this is a really good solution to the problem. So, well, thank you guys for your efforts.
All right, everyone, that's great. That's the last presentation for the day.
Oh, wow, we're closing out.
Yeah, we'll be here again tomorrow, though.
Awesome.
And the day after. Did I mention the day after that too?
Yay!
We're no short on excitement. Bogdan, do you have any closing statements, thoughts, feelings?
Besides, it's not over yet, and we will continue tomorrow, not at this moment.
So you're putting us on an eternal hold.
We are just warming up. That's the first day, you know.
It's going to start raining refers around here. Okay, so let's get into the raffle channel for all of you that are still here, that are dying to win one of these amazing prizes. Is Livio gone?
No, it's over here.
I'm here.
Oh, well, okay. Hey, can you start up the Livio 2.0 AI?
You want me to do it? Or, I mean...
Yeah.
Listen, I told you, I was underqualified.
AnalyzeData, guys, can you stop the presentation?
Okay. So, we're going to go for the t-shirt, right?
Yeah, do you want to share your screen for the summit raffle?
You want to see the AI?
So we're going to have one of these.
Okay, I can share the...
Share if you would.
Black, I guess. That would be fun.
Razvan!
So, let me see if I can do it. Okay, this is it.
Present.
All right. Where is the other window? I have some...
So we are going first for the t-shirt,
I had some test here. Wait, one second, I have the copy paste.
So in the meanwhile, to be eligible as a winner, you have to be online on the summit raffle, and you have to answer.
I'm ready.
If you get your ID.
We're only allowing 200 milliseconds of latency, by the way, so you better have your fingers on the button.
How much is the timeout?
Okay, so let me know when you guys are ready.
All right, this is for an authentic, one of 200 kind Summit 2020 t-shirt.
All right, let's do it. And what happened? Did it pick anything?
No.
Maybe.
Oh, finally. Oh. it took
so the winner.
Do we have Slava
Bendersky? Are you here? Are you here? Man.
The channel is pretty big, so it took the Apple
Hey, there he is!
Slava! Congratulations!
Nicely done.
Okay, so
all right, Livio.
So one second.
This goes off. What? Yeah.
Hold on. Slava, you'll need to send us some information about the size of the t-shirt that will fit you. Okay. So just send it You can send it to me offline on Slack. So
Also, send your social security number and credit card number.
okay, next.
All right, so before Liviu clicks this pick button, I really want everyone to understand and appreciate the magnitude of a prize like this. You're going to spend an hour with some of the faces that you've seen today, some of the geniuses of our industry.
With or without the t-shirt.
That doesn't mean you can be naked.
No.
Let's just make sure, Bogdan, you understand you're on a national forum here. What he wanted to say was, you don't have to wear a t-shirt, an OpenSIPS t-shirt, but you must wear a shirt. Shoes and shirts are required for service. So without further ado, and a mental examination are required for service. So without further ado, the winner of this 3600 TTL shakedown with the 3 dudes in front of you from the OpenSIPS core team. Liviu, Richard.
Oh, wow. It's going to take a while. Wait for it.
That's okay. The AI is learning.
Right.
Crunching data. Oh, really?
Awesome!
So we know what we're using that ticket for.
Good one.
There's some guaranteed work on some integration with that amazing piece of software we just saw.
Yeah, definitely.
It's almost like the VoIP gods are telling us this needs to be done.
Yeah, this is a big hint, guys.
Well, that's awesome. Well, ladies and gentlemen, that's going to be the end of our presentation for the day. We'll be back here at the same time tomorrow for about the same amount of time, God willing. And we'll have some amazing speakers and some amazing prizes. And we thank every one of you. There was a lot of you watching. I know there's going to be a lot of you that are going to go back and check this out today and see what it was like. You guys are what makes this possible. And you're our motivation for all of it. And we thank you, all of you, for supporting this amazing project. Bogdan, any thoughts?
Nothing to share with you, actually. No, was just joking. I think it was a really, really good start for the event. I was a bit nervous, before this, because it's the first time doing the online thing, and there are so many people to work with, contributing in different ways. In the same time, there are so many activities and channels to manage: the conference, the YouTube, the the Google Meet, and so on. So I was just hoping that everything will work fine, and well, everything worked fine. Or if something was let's say not working perfectly, it's more or less irrelevant. I mean, I think everybody had a good time over here. The quality of the discussions were good. So the idea is to keep up the same for the next 4 days, right?
Yeah.
Exactly.
Okay.
Thank you, Max.
Yeah.
And
Round of
again,
applause for Max.
everybody, Max, he did an amazing job. Everybody got distributed.
Yeah.
Don't make me cry.
Yeah. So tomorrow we will continue exactly with the same time layout.
Maybe cry, all the tears will break his computer and will not be able to broadcast anymore. So watch that.
He's the only guy I know that can actually cry a river.
Just don't touch anything.
By the way, ladies and gentlemen, there will be prizes again tomorrow. I believe tomorrow's grand prize is going to be a 1 hour sit down, mano a mano, with the creators of the Homer project over at QXIP.
Yay.
Nice.
So That would be really interesting to see if anyone from AnalyzeData will get it also.
Our AI is everywhere. You know that now.
I was on myself.
The IA can be influenced.
Well, we will have Live AI 3.0 in full action tomorrow.
For sure.
All right. So with that, I think that we're going to wrap it up here for today. Everybody, enjoy the rest of your day. Thank you again for coming. And we look forward to seeing all of you tomorrow.
Exactly. Thank you, Alex. Thank you, all of you, sorry. And good evening, good afternoon, or whatever. Have a good one. Okay?
Bye, guys. See you tomorrow.
Bye, all.
See you tomorrow.
Bye-bye.
Thank you.
Cheers.